Mikrofonai dirba?
Ne.
Ne?
Dar turim kelias minutės.
Taip. Labas rytas, Leonai.
Oh, hello. To everyone outside. Tai gal tada pradėti galima, ne?
Okay. So, good morning, dear colleagues. Let me open the 25th International Conference, Electronics 2021. And I would like to start the conference with the slogan, "The future belongs to electronics." This motto was chosen this year for a marketing campaign to attract more young people to study at our university. But I am sure it's not just a slogan, it's an undeniable truth. Of course, I sincerely regret that the promise to meet in Palanga this year has not been fulfilled. It's always better to meet people face to face. But anyway, we are very fortunate to have built up a network of international partners across the world. And the international conference, besides everything else, is a way for us to learn from the expertise partners can provide and also strengthen built on our present partnerships. This event will give you the opportunity to meet colleagues from partner institutions and widen your own circle of professional contacts. And as a tradition, we have two distinguished invited speakers at the beginning of the conference. And of course, working sessions will allow you to present your area of research and connect with other researchers in the same field. So I wish you a good luck, fruitful discussions, and good new experiences. And now I would like to ask my colleague Darius to provide more detailed information about our conference agenda.
Okay, just a minute. Okay, so good morning, everyone. My name is Darius Andriukaitis. I am that person who contacted with you many times, sent many emails, and tried to solve all issues related to the conference. And it is my pleasure to welcome you unfortunately online today, not in Palanga. But I foresee that the future might be bright, and I hope that we will meet you next year in Palanga. And usually I do some presentation about conference, about facts related to particular year. And I would like to say that we have 2 anniversaries this year. So it is 25th conference, international conference. And another anniversary, probably it is more important to us, to organizers, because 10 years ago, the form from the organization point of view was changed to current one, and we have a bit different form of this conference. Previously, it was organized in a bit different way, but currently we have 3 days conference, usually with social events, except only recent 2 years due to pandemic. And many partners, many colleagues, and I would say friends, came from foreign countries, and we established, and I hope you established as well, some good connection with conference participants, and you do communicate or collaborate in one or another activity. So I'm just glad that we already 25 years organizing the conference, and 10th conference in current form. So I would like to present a map of applicants, and as you see, we received application from all over the world, from 29 countries in total. Usually we do receive at the same number of partners, of colleagues from different countries, and such number, I think it's like a constant. The most popular topic is electrical engineering, and according to the papers, more of the papers are practically oriented, and as we see the trend that we have a lot of papers who present not only theoretical but practical validation and some comparison to the already published papers. So it means that the level of the papers a bit increases, and I hope that for the next year we will receive higher quality papers, and you will get some experience during the conference as well. The review process was quite strict, and the rejection ratio is around 54%, while last year it was 63%. The average, I try to calculate, the average is 63%, so more or less it is quite stable ratio. And you already got some information about the presentation time, and you probably read in the conference program. But just in case, to avoid some misunderstanding, so I would like to remind that all participants are invited to connect 15 minutes before the session starts. Chairs are invited 20 minutes before. And we would like to ask you to switch off camera and microphones in order to avoid some noise. And during your presentation, you will be asked to turn on your video camera. This year, all participants and all, not only participants and program committee members and maybe somebody from outside, your colleagues, are invited to join to the sessions directly to the Zoom rooms. We hope that the participation of all members in one room, not only watching over YouTube, will bring more fruitful discussions. And I will try to assist in all sessions in order to avoid some misunderstanding, but I hope that everything is already solved. But last year we had some experience with some electricity loss, so anyway, I will be around you, and I would like to invite, not yet, sorry, but I just want to mention that we have two invited speakers, as conference chair said. As usually, we have sponsors. So this year we also have sponsors, and Lokmita, local company, with the help of international partners, organized presents for best presentations, soldering station and oscilloscope. And in the end of the conference on Wednesday, everybody will get a direct link to vote for the best presentation. And during the closing session, we will announce who will win. And I hope that you will have possibility to join to the our closing session. You see the picture below, in the end of the slide. I hope that this year we can create something similar, and maybe not all of you, but majority of you will join to the last session. So I invite you at 1:30 p.m. on Wednesday to join the room A. And thank you, and have a nice conference. And I would like to invite the first invited speaker, Professor Dr. Wlodek Kulesha, to make presentation, Applied Science Future, Scientific Alliance of Academia and Industry, VTH Bioseco case study. So, stage is yours.
Okay, thank you very much. And now I have to deal with this technical issue that everything is working, because this is always a little bit scaring if I can share what I want and so on. So now I have to start my presentation, sharing screen. And this will be this one. And if something will be, oh, did I? So this will be here. Okay, does everything working correct?
Yes, yes.
Do you see everything? Because the most important is that we trust in electronics, but sometimes electronics put us in some, how to say, try if we know how to use it, you know, because electronics is perfect, but human error is mostly the biggest problem. So I hope that now everything is working. And so this is my first slide. And first of all, thank you very much for continuing this conference and to be honored by your invitation to be first invited speaker, which is quite challenging, because always someone who opened the conference should put, let's say, good quality. I hope that I will not disappoint you, and everything is working correctly. So thank you very much once again. And as you said, I really regret that we cannot make face-to-face connection during this conference, because Palanga was always the dream place, and the conference was so lovely organized, and all the social events, they were so fantastic as I remember. And so second year in law, we don't have this opportunity, but I believe that next year there will be easier and so on. I am talking a little bit slower because normally I should start 10:15, so maybe someone will start watching at 10:15. The topic of my presentation is the applied science future and the scientific alliance of academia and industry. And the case study is based on my experience, is my university BTH and Bioseco, which is the company that I cooperate with. Where is this, let's say, topic from? Why I thought that this topic could be interesting for everyone? Because most of us, we are from academia, and let's say we have some experience with cooperation, but there is still some kind of antinomy between industry and academia. And I hope that my presentation will show the light side of this cooperation, because I am very favor of this cooperation and I really love it. And I hope that I can convince skeptics who, let's say, still have some not the best experience, if I can use this euphemism, of this kind of cooperation. So you see the first slide with electronics 20th International Conference. So this is, I hope that everything is clear now. And this slide shows the pattern of our university. Here in the bottom of this is some graphics of our two campuses. So I am sitting in this campus, is a campus in Karlskrona, and this is a campus in Karlsham. And this is the photo of the campus that I am sitting. So if I can show you, my office is somewhere here, no, on second floor, no, on the third floor. So this is somewhere my office, and this is a sea. So you see that after, when I will be overwarm, I can jump in water directly. Temperature is a little bit still too low, but already I see every day some people swimming in this Baltic Sea. This is challenging. I haven't tried this year, but I plan to do it soon. So Blekinge Institute of Technology, and this is a rather small academia in Sweden. We are not the biggest. Of course, the biggest is KTH and Chalmers and Lund University. But we have very strict or very defined focus, and this is a digitalization and sustainability. So I think that this is something what, of course, is a priority in many countries and many academia and so on. So I believe that is also electronics here, because sustainability is the application of electronics. I think that electronics helping, of course, in digitalization is obviously one of the main issue to use electronics, and sustainability is also very much oriented on using electronics. So as I said, this is not the biggest university, and maybe compared with your universities, we are just a small one. So we have just less than 500 employees, and turnover is about 50 million euro. 50 professors, 100 PhD students, 11 research area, and 11 also PhD programs, because each research area is related to one PhD program. And the third of our activity is related with research. You can see also here a little bit short my CV, just to know who I am and where is my experience from. So I got my PhD from Technical University of Łódź in 1987. So it was a quite long time ago. After my PhD, I had opportunity for 3 years internship, industrial internship in Germany, in Darmstadt. So this was quite important experience in my life, in engineering professional life. And then I moved to Sweden almost 30 years ago. And I got the docent title. This is some kind of Swedish title between PhD and professor chair. It was in 1999 in Linköping. And then in 2001, I became a professor in Kalmar. Then we moved to Karlskrona. So I sit in Karlskrona since 2007. Yes, 2007. I have PhD students in 3 research areas, in applied signal processing, in system engineering, and also in engineering, health engineering. So some 3 areas that I cover. My background is in automation and measurement. So this is what is my background from my home university in Łódź. I am teaching quite much because I love teaching, and now just almost finished with the PhD course for PhD students, which is called Philosophy and Methodology of Applied Sciences. And this year I got quite nice group of 11 PhD students from different fields, which is quite challenging because they have a different approaches, and not all of them are really pure engineering or technical students. So this was quite a nice experience, and maybe the first time I got so big group of PhD students. So this is my background in research and in education. So when we discuss about cooperation and about industrial cooperation, maybe I should explain how does the cooperation work in Sweden, in industrial cooperation with PhD students. Usually the government or state try to support our cooperation. It means that there are quite a lot of projects that if I will find the industrial partner, and my university also wants to invest something in this, the state can support with extra money. So this is one of the ways to cooperate. And the industrial PhD students are quite common in Sweden. It means that it is required that the company will cover 50% of the salary, which will be dedicated only for research, for PhD study. And it means, of course, that this PhD study is a little bit longer than the others, because in Sweden we have 4 years PhD study, not 3 years as Bologna process says, but in Sweden we have 4 years. And it means when this is half speed, the industrial PhD study is 8 years. So it could be, of course, shorter or longer. It depends on many, let's say, factors. And the PhD students are obligated to publish. So normal way the PhD dissertation looks as a book and is mostly a set of papers, published papers. So they are already peer reviewed and so on. My experience that I will talk about today is for last 5 years. So this is not from a long time, because of course it would be very long history, and I will not tell you about the stone era or iron era at the university. It will be a little bit more temporary era. In fact, my first PhD student, she was also industrial PhD students, pulp factory. Pulp factory is one of the richest factory in Sweden. So this was my first experience of cooperation with industry. So the last 5 years, maybe 4 or 5 years, is concentrated on those 5 companies that you can see here on this slide. So maybe we can start with this 3D lab. And this was related to indoor localization problem. So we use indoor localization problem for spatial application for the health monitoring. So we wanted to, for instance, recognize some symptoms of dementia by the observing human movement. People don't like camera. So at home, we shouldn't use camera, but people don't like it really. But when we use this RFID technology, it was possible to map the behavior of person at home. So this was the first experience. Then we have also continue this topic with DAC. This was also indoor localization. And then they moved more in Industry 4.0. And this was about monitoring of milk suppliers. So this was some supply chain and so on. So it was quite interesting because we used different sensors or different technologies to monitor this supply chain. Then we started the cooperation with the CTM. This is the institute which works mostly with marine sea issues, and also the new things in this case was autonomous system, which I think is the main issue of the Industry 4.0. So before Industry 4.0, Industry 3.0 was more or less oriented on automation. So we automated processes, and it was main issue of application issue. But I think that Industry 4.0 make the step forward, and now we have this autonomous system. It's a lot now discussion about autonomous cars, autonomous ships, and so on. So everything should be almost autonomous. We don't like to have truck drivers, so the trucks can be controlled or drive by the smart system. So this was quite new. And then we started with collaborative robotics. This was a fourth already company, and they got money for research related to the monitoring system, which should help to make the collaborative robots safe for people. So if person is coming too close or any situation happens, the robot should be immediately stopped. This is quite tough job because these collaborative robots became very popular nowadays everywhere, and but it creates a lot of dangerous situation. Even I will not show you statistics, but this statistics says that there are quite a lot of, let's say, even accidents with death and so on. And then the last, but not the least, company that I cooperate since several years is Bioseco. And this is also a very challenging experience because we deal with the localization, but localization of birds or animals or human in outdoor. So this is something what was quite new. And you see on this figure here that we started RFID, then we discuss also about health problems and automation or automation of diagnostics. And this is the collaborative robots and birds protection, what was the next step. Okay, so as I said, at BTH and in Sweden in general, we very much like to send the master students or bachelor student also to make their final thesis at company. And this is very beneficial for company, beneficial for university, and beneficial, of course, for the students. Why? Because the company gain quite a lot of new knowledge from those students. They are very active, very eager to do new things. And this also create my opportunity to meet people from industry, because industry appoint the supervisor from industry, and I can become the academic supervisor. So this is something what is a meeting point of academia and university. Sometimes this cooperation is, let's say, lasting for longer. Sometimes it's just one project and so on. Recently, I had some projects in Volvo, in Göteborg, and also in Stockholm, in Scania. So it's quite interesting project because they have real problems and we provide them some solution. So, but those two projects that I said already, they were not related to PhD students, but 3 projects that I got last 5 years was related to Bartosz Jachimczyk real-time locating system for indoor application. And this was DAC company, and they accepted 2 master theses in 2018, 2 master theses in 2019. So 4 master theses, which is quite big impact on the small companies. All of those companies are rather small. Some of them, they are even startups and so on. So this is quite important for them to get almost for free this research from master or bachelor students. Then in 2019, there was also 1 master thesis related to Interna, to this collaborative robots, and partly it was related to Damian Jack detection and classification of multi-sensor system. Damian and Bartosz, they have already defended their thesis. So they made it, Bartosz in May 2019, and Damian did it on December last year. So this is almost every year I have a new doctor who successfully defends his. Unfortunately, there are not any female PhD students in this set that I discussed. And in this year, in September, everything is almost finished. We will have another defense of David. This is sensors and algorithms in Industry 4.0, security and health preservation application. And he is working in Bioseco. And as you see here on this slide, we have had already 3 bachelor theses in 2020, and in this year's 4 bachelor theses are not finished yet, but they are on progress. 1 bachelor thesis usually consists of 2 or 3 students. So this is a little bit bigger than just 15 ECTS. So this depends, of course, on the projects and so on. But at least 2 students join 1 project. We think that is also good for them because a part of, let's say, making new things, new solutions, funding new solutions. They also learn how to cooperate. That is quite important, that this cooperation between students is working. All these theses, including PhD theses, all master theses, and all bachelor theses in Sweden are open for any readers. So you can, if you are interested in these topics, you can find on BTH database. It is bth.divaportal.org. All theses, full electronics. We don't print, we print only PhD theses. We don't print any longer bachelor or master theses. All master and bachelor theses are only in electronic form, and all of them, they are in public domain. So anyone who is interested in reading or funding some solutions can find it. So this is quite, I think, also innovative and, let's say, helping everybody. So this was about PhD thesis, about the bachelor thesis and master thesis. But now I want to show you also the academic outcome of this cooperation. So, but there are just, let's say, 4 papers and 1 UK patent application. So for the last 3 years of the cooperation with Bioseco, we have written 3 papers, and we apply for the patent, which is in progress and is quite promising. We got already first feedback, and it seems to be that we will get it, maybe with some changes, small changes. A part of this, we had a paper related to this collaborative robots, and 1 paper about the IoT-based diary supply chain and ontological approach. As you see, there is mix of, let's say, journals, but at least 2 of these papers were published at Electronica and Electrotechnica. So this was quite interesting to get this publication in Kaunas scientific journal, which really is developing and making possibility to publish more practical even papers and so on. So this is what is the results, scientific results of the cooperation between BTH, and I will skip this too. I will jump directly to, because I have to control my time, because as usually, as each professor, I love to talk and talk and talk, so maybe I will miss. So this is, I think that every professor has this, that I can talk without limits the whole day. So this is about the cooperation with Bioseco. Bioseco is a rather small company. It's about 30 persons working, but very innovative, very research oriented. And nowadays, Damian and David, they work in this company. So you see that they are interested to employ PhD students or PhD doctors even. So this is quite interesting. And they work with the sustainable development because they want to make the green energy more safe. So this is quite important. I will show you what does it mean from technical point of view. But it is quite important that what we call green energy, it could be also danger energy for some nature and so on, avifauna and so on. A part of this, we had this protection of the rare birds, which is quite important because human, we extend our kingdom and we make the space for the animals less and less. So I think that is quite important that we worry about it, that we care about it. and Swedish-Polish cooperation, but very much supported by the European Union funds. What is quite important that we got this money to continue our research. So what is the market for this Bioseco product, or what are the targets of this one? So in general, there are two targets. One is wind farms. And as you see on the picture, how does it look like? We have this wind turbine and birds around. And what is the problem? The problem is that number of the birds that can be killed by these wind turbines is quite big. And it is sometimes it is not published, but you can find this data. And but this must be really clear that the green energy could be also danger for avifauna, especially for avifauna. And so what is the problem? Of course, we can stop the wind farms when there is some, let's say, migration of birds. You know, the birds, they migrate, especially from Sweden for winter, they migrate to southern part of Europe or even North Africa. And during the migration, without system which could record or monitor this migration, the farms should be locked down. And this was done often. So the system that we want to propose was related to save the life, but also to reduce of the stop of turbines, shutdown of turbines, because it costs money, of course. And so this was a win-to-win situation, not only just shut down the turbine, but also possible to shut down only when it is needed. Another target that I will not tell too much about it today is airport. And 40,000 bird strikes in 2017. And you know, the cost of each strike is $50,000 US. So the amount of money which cost each strike is a part of danger, because, you know, it could happen that the plane will crash because of this one. And what is quite important, that 90% of these events happens at airport area. So there is a possibility to control to monitor the animals on the runway or airports area to reduce life costs, but also to reduce the cost of possible damages. But today I will focus mostly on wind farms, because this airports, which is also ongoing project, requires a little bit different technologies and so on. So just too much would be to share with you. So I hope that you don't mind. If you will be interested, of course, you can find us or me and my colleagues to discuss about this as well. About the genesis of this solution, we see here the wind farms. This is not just singular turbine, but it is a wind farm. So it's a lot of turbines, and the birds are coming from different directions. Maybe they live somewhere close and so on. So we started with idea how to reduce the negative impact of the green energy on environment. You know that ornithologists, they are not very favor of the wind farms. And so wind farms still became controversial. Nowadays, maybe less and less of these wind turbines are placed on the land. They think more about sea shelves and so on. So, but still we have quite many on the land. And what is another problem? Different countries, different areas may have a different expectations regarding which birds and how they could be protected. So this was another challenge, that the system is not just to everybody, because different customers may have a different opinion about the way that they want to protect the birds. So the system must be enough flexible to accommodate all possible, let's say, requirements or demands from the political, for law, or for ornithology. So there are many authorities which are involved in this kind of questions. And of course, we want to help also the owners of these wind farms, because the number of the shutdown of the turbine should be reduced, that they can earn money. And so this is also the target. So there is some kind of balance between the protection of life, but also improving the economical solution of these wind farms. So you see here, what do we think it should look like? So we have some sensors placed on the wind turbine, which observe the movement around the farm. So this is the concept of the system. You see, this is how does it look like in reality. So each of these modules is placed around this turn and observe some angle field of view. And we have, let's say, 3 distances. The ornithologists, they said that it should be up to 500 meters, that we have to detect the danger situation. And it depends on the distance. We may use 3 different reactions or 3 different deterrents. So the longest, this 500 meters, is with strobe light. So this is something what make the birds scaring, and they can move from this area. When they are too close, the next step is to use audio deterrence. And this is also not very nice, because especially it is high frequency, but it is not, how to say, nice for people who maybe live close. So it should be avoided as much as possible. And then when they are in danger, the closest danger area, the turbine has to be stopped. So this is what is the last step. If we cannot make possible that the birds leave the area of danger, the turbine has to be stopped. So we have to have enough time to stop it. And it is quite possible in a few seconds just to start turbines and to protect the life. Okay, so this is another example, and you can see here the pictures. The solution is, of course, based on vision system. It means that it works on daylight, and it is very difficult to make infrared, because, you know, birds, they have a protection of heat. So you cannot see birds with infrared. So if you would have a question, why not infrared? Because it's really difficult to see the birds, even if they have the constant temperature, but they are so small, they have very energy safe construction. So they protect any, let's say, disappearance of energy. So this is a single bird protection system module. And on next slide, I will show you some, let's say, what it consists of. So we have here two stereo vision cameras, which are used to observe. And why do we use stereo vision? Of course, because we want to estimate the distance of the birds from the farm. And because this is vision system, there are quite a lot of problems to detect moving object and to distinguish birds, for instance, from clouds, because cloud can imitate shape of birds or whatever. So we use the vision system, and we have here this double strobo to make the light, and we have also double audio system to generate the audio signal, and we have even the camera which does not belong to the stereo vision, but it controls the movement of the, so we record it for safe case and to compare results from different systems, let's say. So this is how does it look like. So high density stereo vision together with detection algorithms, and we have a strobe and audio deterrent system and turbine shutdown module. So there are, let's say, main hardware components of this one. What is required? So it is required that the system is working in real time. This was also something what is quite important, that real time is obviously required. There is no way to stop turbines in a proper time. So for this reason, we need to identify and classify the birds, because we have to estimate the time that they need to come maybe to closer to turbines. So we want to localize the birds and we want to track them. So you see here on this picture the sequence of the records of the birds which came closer. Here is the closest instant, maybe after this is leaving, and so on. So this is how the tracking system is working, that we observe, we can anticipate birds' behavior as well. So to cover 360-degree around each turbine, we need 8 modules, because each module has the horizontal view of 45-degree and vertical of 60-degree. You see that what is interesting in this solution, that the cameras are oriented on sky, not on the, let's say, horizontal way, but it must be up to the sky to observe the whole sky and to eventually react for this one. So this is the way that this turbine is in the middle, and each of the modules covers 45-degree and 60-degree in vertical observation. I just try to control my time because I have to finish at 11. So this is, as I said, usually. Maybe we can skip some slides. So when we discuss about test, because this validation or verification of a system is very crucial. So we have to prove that the system is really working. And there are different ways. The most common is to ask ornithologists to sit and observe the sky, and they evaluate if our system react correctly or not. And what is interesting that the system sometimes sees more than the ornithologist, than human, because human can be distracted by some behavior or something and so on. So the system is very reliable because it does not need to drink tea or coffee and does not need to go to TOA and so on. So the system is really 100% of time using. And you see the result that we have got from the independent organization in Germany of our system version 2019, and the efficiency of the spatial bird, red kite bird. So this was 96.8% of the reliability. So 30 of 31 birds, they were detected at distance 200 meters. For distance 200 meters was, of course, worse, and it was 49 of 61. And in the case of the 400 meter, it was just 54 of 88. So rate is 61. But you know the distance, longer distance, it means that we have still time to detect it. So there is always possibility to react. And false positive rate was 7%, so it's not very big, but only 2%. So it means 1/3 of the 7% would require to stop the turbine. If false positive, it means that there was no bird. It was, for instance, the cloud, and it created some reaction that the turbine was stopped. So only in 2 cases of 100, it was required to stop the turbine. So this is another test already done in Poland for the version 2020. And because we improved the software, the hardware is working quite stable, but we can use more AI-based tools. Usually this is a convolutional neural network that we apply here for bird classification. And the system, the localization is based on the movement detection and stereo vision, but the identification is based on convolutional neural network, which helps us to improve the solutions. And of course, the neural network, which is, let's say, more sophisticated due to the more examples and the history, works better as well. So this probably helps also. So I don't need to make too much now. I think that I have to go to final maybe slide. So I think that I convince you, because I am always excited by this research and by the opportunity that at university, when I am sitting here in my office, I wouldn't have this opportunity to install this system, to improve it and so on. So I think that the cooperation makes my life really exciting, because I went with my colleagues to the place and I observed it, and it was in real life. So I believe that future of research is in cooperation between industry and academia. And of course, it depends on the personal experience, but I really recommend you to find good guys, good companies which are interested in the science, in research. And I think that you will find money for this, because this is possible. More and more, let's say, funding is dedicated to this kind of cooperation. So I have some questions here in the bottom, but I don't know if we have any time for questions. So thank you.
Okay.
Děkuju, tak, dziękuję, whatever languages you know. 谢谢, maybe some Chinese people. Okay, thank you, Darius.
Okay, thank you. Do we have any questions? Okay, so I have questions until somebody will ask you also. So, well, if there is any good answer, or maybe medicine, how to establish cooperation between higher education institutions and companies? How to establish reliable and sustainable cooperation? What is your point of view?
Yeah, you know, it is human, let's say, machine, human to human machine. It means that it depends very much on your relationship with this person. If you have a good relationship, personal chemistry must work, you know, so you have to trust to each other and so on. So as you see, my Damian, David, and Bartosz, they are very happy to cooperate with me, and the companies as well. So I think that it depends very much on person to person. So you have to find the person whom do you like, and he or she likes you, and cooperation will work very well. I guess it's the easiest way.
But I suppose both sides should have intention to make, yes, to make.
Yeah, you have to be open-minded, of course. You know, I think that sometimes it's even more difficult from companies' side, because they think that we are academics and we are only in clouds and so on. So they're afraid that we want to publish only and so on. But now with the funding from European Union and from some research, they require also the publication. So what makes the company happy, because when we started, and now I show that we have so much publications at company, they say, yes, it is so easy to report the, let's say, outcome of the project, and nobody has any doubt about it. But they have to believe that research is useful for them. This is not easy, not.
Yes, and what about outcome? Do companies expect research or final result, let's say like a system or something similar to system, that maybe a light prototype or something else? What is your...
Of course, you know, they need money, so they need the product. But if they got support to develop the product from a research council, and they require the publication, so it seems to be, but they see, I think that I convince my colleagues now that when we make research on deeper way, they understand their system better, and they can improve the system, because this is always, you know, when you just do the product, you are on the surface. But when you dig with details, with models and so on, they find, oh yes, this is something what we can, the analysis is not the best, let's say, at industry. Usually they make the product, but they don't understand the product so well. And even big industries, you know, like Boeing and others, you know, the accidents happen. Instead to dig it in problems, they just make the product, already sell it, and apparently there are big accident and so on. So this is something what has to be clear, that research really helps them to understand their system and to improve the system.
Okay, thank you. So do we have any questions from auditorium?
Dear, may I have a question, please?
Okay, please.
It's from Turkey, Fikret, Fikret. We have an institution called TÜBİTAK, Turkish Technological Institution and Research. This institution supports common research between the universities or companies from different countries, especially from European Union countries. Turkey is contributing to this common budget, so the institution is really keen to support such research. My question to Professor Vlodek is, will it be possible to propose a common research, to make a common research proposal to TÜBİTAK, the Turkish?
Absolutely. I am always hungry of new challenges and new proposals. So
thank you.
Darius knows that we always searching for some new cooperations and so on. Everything what is related to sensors, AI, algorithms, and so on is in my field of interest and so on. So absolutely, I am interested in any research.
Before, well, I contacted TÜBİTAK and I asked them whether they will be keen to support a glucose, a non-invasive glucose measurement, biosensor or nano biosensors, and they keen to do such research. As one of your research area is health engineering, I think it might be interesting to you.
Any non-invasive measurement is in my field of interest, so this is absolutely. Okay. So just send me email, you can find my email in this fields and so on.
Thank you very much.
So good luck.
Thank you.
Thank you, Darius. Thank you.
Okay.
One short question, if possible.
Okay, please.
Okay.
What is your opinion about the patents? Because industry is not very keen to share the intellectual property, yes, but researchers want to publish all the results.
I started to negotiate with the management of the company that we need the patents, but it is very costly. It is also demanding to prepare good patent, and company usually should have this patent. I don't know at different universities, maybe there are different approaches, but in my university will not be owner of my patent. I am owner of my patent. So when I cooperate with industry, the industry is owner of the patent. So university does not in any way wants to share this patent with them, because in Sweden, the university, we may not be owner of any property and so on. But if I will apply for patent in Sweden on my own, I can get the money from some foundations that they help me. I think that it is important to have a patent for companies, because if they don't do it in time and they have really something what is tricky in technology, they need to protect their solution. If they don't do it in time, they can lose. So this is also the time that when we wrote the paper, sometimes we had to postpone the publication, because until you apply, you may not publish. But this is my experience already from Ericsson and Volvo, because they also had the same case. I wouldn't allowed even to publish the thesis, master or bachelor thesis, before they will apply for patent. So they postponed this publication, and this is possible at university, or even, when we have with some military applications, the patent of the report is totally hidden. So this is possible. But the patent, I am just obviously favor of making patent. And I think that academia, when I put in my CV that I made the patent, they don't count it maybe in some countries as some kind of extra points, but at least it is appreciated in my university. I don't know if I answer your question. Thank you.
Okay, thank you.
Thank you.
Thank you. So are there any questions? Okay, so if not, so I would like to thank you to Wlodek for the presentation, for the invited speech. And now we have a short break, maybe not a short, but it is around 37 minutes, and we will back 15 minutes to 12.
Okay. Thank
Okay.
you. Thank you very much for opportunity. It was my pleasure. Thank you.
Thank you, Wlodek. Ar ilgas pranešimas?
Nežinau, 30 skaidrių.
Tai čia kaip pavyks.
Taip.
Dar porą minučių.
Pradedam.
Taip.
Ladies and gentlemen, let's continue our conference. And our next invited speaker is the Vice Rector for Research and Innovation of our university, Leonas Balaševičius. And he is going to talk about some challenges in the field of research and innovation. And the title of presentation is Reinforcing Research and Innovation in Higher Education Institutions. So Leonas, the virtual stage is yours.
Hello to everyone. It's my great pleasure to be invited speaker at the conference Electronics 2021. My background is electrical engineer. I made a PhD in informatics technology and control. And my research interests are related with automation, digital control, and robotics. The topic of today's my presentation is related with our university experience by implementing the European Universities Network initiatives. So the outline of my presentation will consist of the short introduction of Kaunas University of Technology, the opportunities which gives to us the pandemic, how we need to use these opportunities. Next, what could be the strategy for universities if we would like to dynamically adapt to the changing situation. The next one, I would like very shortly to present the European Universities initiatives and the one of consortia where Kaunas University of Technology is participating, and later to discuss the challenges, how we're facing the challenges in research, in innovation, and a little bit in learning in this case. And of course, what makes a good challenge, how we are going to embed that challenge into research and innovation, and how we could try to solve the challenge. So, first of all, I would like to start from introducing the Kaunas innovation ecosystem, because I'm from Kaunas University of Technology. So in Kaunas, we have 4 universities. So these are the main key actors at Kaunas innovation ecosystem: 1 research institute, 2 Science, Research and Business Center. So it's Santaka Valley and Nemunas Valley. And of course, it's about 50,000 students, more than 3,000 of academic staff, and about 30,000 of small and medium enterprises, which forms the Kaunas innovation ecosystem. And the topics which are implemented here are related, of course, with new materials, electronics, energy, food technologies, and chemical industry. Next, if I take a short overview of Kaunas University of Technology, so we have 9 faculties and 8 research institutes. The number of students are around 8,500, and number of academic staff is about 900. We have more than 300 PhD students. What's very important for us, so looking to the new European agenda, so it's gender equality. Of course, from the point of view of PhD students, it's around 50% are males, around 50% are females. But if we go to the different sciences, so in technological sciences, we have 64% of males, and in social sciences, we have 74% of the females. So in some fields, we need to adjust that equality, because in the nature sciences and humanities, the balance is equal in this case. The university provides 19 PhD programs. All PhD programs are provided in English, and the number of PhD candidates from abroad to the current situation is about 24% of the total PhD students. And what I am proud that our university is a leader among all institutions in Lithuania by participating in European Union Horizon 2020 program. So we have a lot of projects implemented among other Lithuanian institutions. Next, what is very important for us, it's university industry or university business cooperation. From 2012, we have established the Technology Transfer Office. In Lithuania, we called the National Innovation and Entrepreneurship Center. So the services which are provided by Kaunas University of Technology, you could see at the website apcisktu.edu, and this Technology Transfer Office acts as one gateway between academia and non-academia. The clients of the university are national and foreign enterprises, public institutions, and other organizations. And if we take a look to the path, we see that we got the requirements from the outside, non-academia. We match these requirements with the capacity of the university, as in research and innovation infrastructure, as regarded the knowledge capacity and human resources capacity. We negotiating the contract and implementing that contract. And after a short presentation of the university, now I would like to go to the opportunities. Opportunities which allows to reinforce the research and innovation at the universities. Of course, first of all, maybe it's the pandemic, because pandemic also is an opportunity to reorient our research, technology, and innovation policy and of course the paths in this case. Next, what we could see that maybe if you go to OECD data, you could see that maybe over the last 2 decades, a lot of funding was dedicated for research and development that was related with industrial research and development needs. And even it goes through the tax incentive. And also a lot of funding was assigned to the research in universities. The pandemic gives to us a new approach, and we need to redirect the public support to societal challenges. And in this case, maybe what we could face in the future, that the main elements of science, technology, and innovation policy reform should tackle the challenges of sustainability, inclusivity, and resiliency. So what will push universities? That means this will push universities to mix to the target social challenges. I think to reform the PhD training, that it supports the PhD graduates' career path diversity, and of course, implement global solutions for global problem in this case. And the last may be the transdisciplinary approaches are needed to deal with complex, multi-faced problems. And I think what should do universities in the future, that means to promote transdisciplinarity. The next one, we're also regarded with opportunities. We see that COVID-19 demonstrated the need for scientific advice, that is multidisciplinarity, and plus additionally transparent to build the society trust in this case. Next, what was mentioned, sustainability, resiliency, and equity changes, call for socio-technical transitions. That means not only one electronics or just IT technologies, but we need to match with other disciplines in this case. So we need to co-produce useful knowledge, including citizens, including businesses, industry, and even the governments of our countries in this case. And regarding transdisciplinarity, we see that it faces obstacles requiring the reform of funding, even inside the universities. And what we need that research which promotes the knowledge or production at the scale. I put here a short introduction of the transdisciplinarity research, and we see that it features both interdisciplinarity and co-creation with actors outside of academia in this case. When we're talking about the co-creation, that means co-design of the research and co-production of the knowledge. As you can see here from this figure, we see that several related modes of research overlaps here with transdisciplinarity research, but do not necessarily incorporate both interdisciplinarity and co-creation. And we see that team science, convergence research are characterized by the integration of different disciplines, whereas action research and operational research and development research very often involve co-creation. Citizen science can be defined more or less broadly, but not necessarily involve either interdisciplinarity or co-creation. The overlap between different terminology and concepts can be a significant obstacle. to effective communication and collaboration across different communities. So indeed, that transdisciplinarity research sometimes mistakenly identified as being exclusive to the social sciences. No, it's not true. And in that case, we have disregarded as potential approach by those coming from other domains. Looking to the future, to the initiatives which comes from Horizon Europe, from European Research Council, the European Institute of Innovation and Technology, we see that transdisciplinarity research will be dominated, and even the nature sciences, technological sciences, we will be pushed to cooperate with social sciences and humanities to solve the challenges which we are facing. Also, we could use that picture when we talk about the innovation community. In this case, we could tell that modern instantiation of the long-standing partnership between science and technology. So what we have related frameworks, including responsible research and innovation, open innovation, and social innovation. Each of these methods has different aims and, of course, focuses, but we share similar fundamental assumptions, including about validity of different knowledge sources, and of course, importance of complexity and the need to engage with the knowledge and values of relevant stakeholders. The last opportunity I would like to mention, that's opportunity related with artificial intelligence agenda at the Europe. Recently published, the European Commission coordinated plan on artificial intelligence foresees that we need to align even at the university level the artificial intelligence policy that addresses the global challenges. Next, we need to invest in artificial intelligence to lead in development and uptake of human-centric, trustworthy, secure, and sustainable AI technologies. We need to engage with industry and general public in development and uptake of AI technologies. Of course, when we're talking about the artificial intelligence, we see where we could apply that knowledge. And of course, it was related with climate and environment. It is related with the improvement of the health. It was related with the robotics and automation. It was related with public sector. It was related with safer mobility and less polluting mobility using the AI, and of course, sustainable agriculture. In this case, the plan foresees the building strategic leadership in these sectors I mentioned, and of course, inclusion of green artificial intelligence component in university and higher education, artificial intelligence curricula, and of course, other training courses and programs. Next one, we see how fast changed the higher education sector with deep technological and structural change that affected teaching, learning, research. And that was accelerated particularly by COVID-19 pandemic. And if we look to the future, when we're talking about the strategy for the universities, we see that higher education sector is key for finding solutions toward a sustainable and, of course, more digital future, and focus on inclusion, innovation, digital and green readiness, of course, international competitiveness, and fundamental academic values with high ethical principles, and of course, employment and employability. We have to act here at the Europe regarding the European research area for research and innovation. If we take a look to this document, we see that it emphasizes the fact that research in European Union is lagging behind in patent performance. What does it mean? That means we need to switch from the research output, how to produce the technologies, how these technologies goes into industry and business. So the key competence in European research and innovation area should be the entrepreneurial culture. That will be the focus in this case. And what we need to do here, we need to focus on translating the research and innovation results into sustainable business. Next one, what is very important, that new European research area for research and innovation supports the sustainable development goals. And I think all universities which performing the research and innovation should care about these SDGs. And the next one, what is very important, we need to incorporate the principle of scientific and ethical integrity, so to prevent the losses in human health, funding, and even scientific failure. So what I could summarize, that it is necessary for the universities to bring closer the four missions. That means education, or research, innovation, and service to society, by creating the knowledge ecosystem approach. How we could implement this strategy for the universities? One of the initiatives promoted by the European Commission, it was the European Universities Initiative. At current moment, we have an example of pan-European cooperation to address global challenges in 41 pilot European universities. In all these 41 pilot, more than 280 higher education institutions across all parts of European Union are participating. And what's important here, that this European universities is an ambitious long-term vision to build the universities of the future in Europe here. And what we see, that this is ambition to build transnational alliances of higher education institutions and to develop long-term structural and strategic cooperation, which will be based on common values, agreed principles, and of course, with the shared goal of achieving sustainability. What's important here, even if we take a look to Horizon Europe program, we will see that there will be available calls to build up the capacity of higher education institutions on where research and innovation dimensions to prepare best for next call on Horizon Europe. And of course, to support collaborations with more experienced counterparts in order to access the excellence and to broaden the talents capacity in this case. What's important here that researchers from around the Europe, regardless of their geographical location, will be able to produce and have access to excellent results, because it will give an opportunity to attract and retain talented researchers. And I think this is the key for knowledge diffusion across the universities. Next, what's important here, that we could reinforce the role of the universities as central actors in innovation ecosystems, and very strongly including or growing the academia business cooperation and transfer of knowledge, and of course, knowledge valorization in this case. Incentives for researchers will be to pursue a career outside the academia using the different schemes. It could be some internships, it could be short-term visit, or even not only to the industry, but also to the business. And looking to this, the alliances, these 41 pilot alliances, should develop a joint long-term strategies for education, research, and innovation. And of course, the strategy should match and give some result that means structural and sustainable impact at all levels of each institution which participate in these alliances. One example I would like to present you is the ECAU University, one of the alliance in which participates Kaunas University of Technology. We, together with other 11 universities across the Europe and associated partner from Mexico, implementing the ECAU University, which together combines about 300,000 students, about 27,000 of academic staff, and about 500 research groups in the alliance. The goal of this alliance is, first of all, to create the open community. And open community means that we need to create model of challenge-based innovation, research and education, and we need to integrate the needs of society, research and industry for personalized learning in this case. Of course, the ECAU University focuses on one sustainable development goal, that means 11th sustainable goal, smart cities and communities. And the idea is to help to Europe to achieve the sustainability. Of course, the leading principles are the needs of individuals, stakeholders, while stimulating the collaboration in innovation, learning, and research. What we are going to do, we are going to establish a hybrid digitally enabled space, which will allow communities to collaborate across boundaries. Keep in mind, we are around Europe. The next one will be digital transformation. That will be the core of ECAU University, and that should enable innovations in education and research. What we are going to do, we are going to apply cutting-edge technologies broadly, such as artificial intelligence, big data. We are going to test new concepts in this case. And of course, what we are going, again, we are going to exploit far-reaching data-driven opportunities. That means we are going to open the data for each other. Next, the ECU University, it will be the innovative test bed of combined European education and research area in this case. For staff or for researcher, it will be a flexible and agile testing ground for novel research, education, and innovation outside national boundaries. Of course, it will be breeding ground for new research models, a space for conducting open research and innovation, and of course, connecting with multiple stakeholders at different level in this case. What we see that cost structure and revenue streams looking to 2030 should reflect the fundamental changes in the role of the future university in society and novel approach to the roles of learners, researchers, and stakeholders. The next one is innovative co-creation model that relies on three factors. It's full utilization of data and digitalization at the functioning European ecosystem with membership, and of course, the strategy based on demand and supply in this case. And what we're doing in research, it's virtual research institute. That should be breeding ground for citizen science with long-term strategic collaboration with society and of course, industrial partners and citizens. What challenges we are facing? Maybe not only the ECAU University, but also other alliances which are participating in these initiatives. Of course, these challenges are related not only with education, but also with research and innovation specific topics in this case. First of all, it's restrictive national legislation regarding the obligations of double or single enrollment of students and PhD candidates in this case. Next, it's very difficult to offer attractive and flexible academic and researchers careers. You know, we're acting around the Europe in this case, and each country has its own regulation regarding the social rights, remuneration, research opportunities, and etc. Next, we see some constraints regarding to the full implementation of the open science. It's in global case, from open data, open science, open research, open innovation. Next, it's very difficult to establish sustainable connections to the external environments. That means open ecosystem approach in this case, but we need time to do this. Of course, insufficient support for incentives for knowledge and technology transfer. Yes, we know that in every country, universities are pushed to attract more and more funding from business and industry to have not only patents, but also to license these patents and to have income from the licenses. Of course, staff involvement, depending from the culture, research culture at each country. So the research are based in the research groups and PIs of research groups. Of course, we having with different interests to participate or just to think or judge the opportunities could give this pan-European collaboration. And the last but not least, I think the level of funding not matching the ambition level, and of course too short term in this case. So we are pushed to be a sustainable one, as sustainable consortium after 2 or 3 years. So it's a big challenge for universities. Now I would like to switch to the challenge-based approach in innovation and research. Of course, when we're talking what is the challenge, any of you could tell where research by itself is a challenge in this case. Yes, and we could agree with you that it's a challenge, but let's look a little bit different in this case. Of course, the good example of the challenge is a pandemic in this case. It's not a problem, it's a challenge, because for the problem, we could apply some solutions, some known knowledges we have, and to solve that problem. In as example of pandemic, so we need to create new knowledge, to apply that knowledge very fast and to see, does it work? Or we need again to redirect our research path to get another new knowledge in this case. What we have regarding the challenge-based learning, so we know that it's well defined. We know what need to do learners, teachers, and how we need to collaborate in finding solution. When we're switching to the challenge-based research and innovation, it's a little bit new in this case. Why? If we take a look, we see that we need new knowledge before the solution can be realized in this case. And regarding the innovation, so we need exclusively to focus on creating the value. And of course, not only creating the value, but also applying the results we get to the different stakeholders, maybe. And what's important here, when we're talking about the challenge-based approach in research and innovation, it's collaboration between all stakeholders. That means solution providers, adopters, challenge owners, and all these stakeholders need to contribute to these challenges. Now regarding the research versus innovation, what we see that research is more about getting new knowledge, and innovation is about transforming knowledge into a product or service. That means creating value. In other words, where research is investment of money or investment or funding, and innovation is how the knowledge are converted into the money again. And if we take a look the research versus learning in this case, so learning is about acquiring new knowledge, and doing research implies learning. Learning doesn't imply doing research in this case. What makes a good challenge? Let's say if we have enough resources and a solution is readily available. That means if we would like to solve a real challenge, we need resources. But in case we have resources, it doesn't guarantee that we are going to solve the challenge. Of course, we are not talking about that, how much does it cost in this case. For the challenges, let's say we have enough money it will not bring us closer to solution, because the true challenge goes beyond what money can buy in this case. And what we could have as consequences here. In case for research, the key is to identify the unknown, of course, new knowledge. And for innovation, the key is to identify the value of potential solution in this case. What are characteristics of the challenges? Of course, it could be socially or business or economically relevant and urgent in this case. So all stakeholders need to recognize the significance of the challenge in this case, and keeping in mind that very often we have that there are other challenges. One challenge could have less priority, we have limited resources, and we could assume that many other challenges are more urgent in this case. Easy to explain to diverse audience, that means challenges well understood in this case. So it's the poorly understood challenges may lead to irrelevant solutions. The COVID-19 may be a good example of the challenge is well understood. The diverse set of stakeholders is needed to solve the challenge in this case, and we need to involve the citizens to identify the problems. We need to involve the researchers, business analysts to analyze and resolve the problems. We need to involve the engineers, consultants, and maybe policymakers to design and implement solutions. And of course, again, we need to involve the citizens, which directly works with the solutions in practice and provides the feedbacks. Next one, the sense that the challenge can be solved and there are truly open questions in the case of the research in this case. So we see that the sense of solvability doesn't imply that we are dealing with the only applied research. It could indicate that we can identify a potential path toward a solution in this case. And what's left here, the degree of wickedness in this case that makes the challenge perhaps too complex for participating parties to handle. And you know that degree, its missions seem to be often wicked problems in that case. The next one, what characteristics could we put regarding the innovation? So in this one, challenge requires no new knowledge. So open problems are engineering and or design problems. In this case, a sense that there is a complex value problem in this case. I'm looking to the time and I'm going to be a little bit faster. How we could identify the challenge? Of course, maybe the main problem in research is identifying the challenge. But looking to the different stakeholders, what we could say that academic staff, that means researchers, teachers, we have some experience by identifying the challenges, of course, with the support of the industry, business, and other stakeholders. If we take a look to the current challenge-based research description, so people are going to talk about the big idea, but the big ideas are questioned in this case. Of course, from an academic point of view, the big ideas are formulated in research programs. The research programs very often are formulated by research funding organizations. In some cases, of course, they could be for internal use, for example, lab on a chip, ethics by design, hybrid artificial intelligence, and etc. But to have a big idea, of course, is good, but having a good big idea, it will be more harder than just a big idea. Why? Because a good big idea is one that can be used for deriving a good challenge. And if we go into the solution of the challenge, what we could see that, of course, it's like a puzzle, and we need to use the divide and conquer approach in this case. That means to split the puzzle into the small parts and try to solve that puzzle. The next one, how we could manage. So we could manage it vertically, horizontally, or mix of them. The verticality means that different actors or teams that solving the challenge. Later, we need to match the expertise of these teams. And of course, the main problem is how to bring the different sub-solutions together. In case of the horizontal teams, we're using definitely this multidisciplinary approach. And the main problem here is that maximal diversity also demands a lot of efforts to understand each other language. The next one, there is a lot of literature what is related with research methods and techniques that could be applied to challenge-based research. And maybe the main tips here, how to form the teams, how to involve the stakeholders, how to articulate the challenge, how to create the plan. That means how all these stakeholders are going to act for one goal, and of course, to focus on producing the final result in this case. And when we are going to address challenge, what we need to do in the research programs, so we need to address the topic, which has a lot of unanswered questions. We need to focus on knowledge development. We need to focus on the theme. We need to focus who is participating and which stakeholders representing. And of course, we need to take care about a lot of sub-problems in this case. The next one, can we expand the criteria for challenge-based research projects to the programs? The answer is yes, in that case, and criteria for good challenges hold for programs as well as for the project. I'm looking to the time. I'm sorry, I'm going a little bit to skip some part of my presentation regarding the cooperation between the different institutions in this pilot program and what is related with challenge-based research. First of all, what I would like to add, in case we have very good definition for challenge-based learning. So the statement of challenge-based learning is in sharp contrast to the criteria we set up for challenge-based research in this case. The role of the stakeholders, it differs, and they could be challenge owners, solution providers, or adapters. The description of the citizen science from the European Commission, you will see here how we are going to engage the citizens. From point of view of ECAU University, what we're talking about the citizen science, we're saying that, okay, the citizens also could have additional roles. That means it's enforcer, self-tester, and requester for help. So we would like to expand the roles of the citizens. And I would like to finish my presentation just with a question: where do we want to go? And showing you the picture from our new advertising program to the electronic, attracting the students to the electronic program. So where we would like to go into this tunnel of light. Thank you.
Thank you very much. So, do you have any questions from audience?
Okay. Maybe I have one.
Okay.
We had heard a lot about challenge, but I suppose scientists sometimes are trying to avoid challenge because any challenge may become a headache. So is there any recommendation how to avoid or how to eliminate possible headache? And even if we participate in international programs, how to reduce possible risk, and that challenge will motivate scientists working on the project for the whole period. So that the question was mainly about headache.
Thank you for the question. It's a very good question. But I would like to focus more not on the challenge regarding our research. Because if we are looking to forthcoming programs, especially from research funding organizations, we will see that always be related with the missions the European Union are going to implement, and the missions are related with the challenges, how to solve the challenges. But what you are asking, I will more focus on the risk management, because the challenge is not by itself the challenge in research, but sometimes when we have the very big team which implements the research in the project, for example, the risk is how we are going to manage the relationship between different stakeholders. Doesn't matter it's researchers, business, or society members included into the project team. So the main challenge is here, the communication between the different stakeholders when you implementing the project, giving the direct action plan for each member of the project regarding from an institutional point of view, putting the responsibilities, putting the deliveries, and of course, communication. And here the main role plays the project leader, the team leader, who is responsible how he or she is going to manage the project. So agree, but still now, this is the biggest challenge from point of view of our university.
Okay, thank you.
Thank you. More questions?
Hello there, Ismail. I have a question.
Yes, please, welcome.
Thank you very much, Professor Leonas, for this very comprehensive and teaching talk. My question is, how can we act to do correct exams nowadays due to this pandemic? Because to do safe exams is a big challenge nowadays. Your talk was more than comprehensive than my question, but this question is a challenge for me. That's why I just wanted to hear from you. What do you think? What can we do?
It doesn't touch the idea of challenge-based learning in this case, but your question is related to challenge-based learning. Just maybe 1 or 2 years ago, at a lot of universities, we're not very wide used, for example, Moodle or other platforms, which allows for us to check the knowledge. One good example from the experience of our university, I could tell. So it was very fast grow by using the Moodle system, by transferring all subjects into the Moodle, and of course, by preparing the, let's say, test for half-term examination and the final examination for the students. And this test, which consists maybe from 40 to 60 questions, as for example, for final examination, just allow for teacher to check the knowledge of each student, because when you have tete-a-tete discussion, of course, you are limited how much question you could ask and you could discuss, just limited by the time in this case. In the model, when you are applying the test, you could give for the test, for example, 90 minutes, and you could look how each of the students answering to these questions, and the system automatically gives the evaluation from the student knowledge in this case, and what's left for the teacher just to see what is amount or what is the influence of the final exam on the total mark of the subject in this case. So I would like to encourage all of the lectures to apply and to use the digital capacities we have at universities, because it brings even from the other part to the students that it will be not the opinion of the lecturer, he or she likes or doesn't like that student, because just the system evaluates the knowledge. And idea of how we could promote in the further looking to the examination, especially online examination, to apply some artificial intelligence method at the beginning of the course to identify the knowledge of each student and to create a separate path, learning path in the subject for especially for that student, that any student at the end of the course have the same level of skills and competences the model, the subject are going to give. But it's our idea in ECIU University, what we're trying to achieve.
Thank you. Thank you very much.
Thank you. More questions? Okay, Wladek.
Okay, just maybe thank you for interesting topic and presentation, because it is in some way in line with my presentation, as you could maybe notice, because this is about the communication, you know, between different groups, between different specialization and so on. In academia, we have the tendency to build the boundaries, and I think that it's important to create some meeting place where the students or researchers of different backgrounds and interests can meet and discuss, because there's sometimes this hermetic language stop to make some obstacles to communicate. Do you have any idea how in your place you can create such, let's say, place of meeting people of different backgrounds and interests and so on, that they can apparently can find something and be more creative? Do you have anything to say about it?
Thank you for the question. I'm not went deeper in my presentation when I talk about the Virtual Research Institute. Here we have, let's say, a challenge, how to bring on one arena the researchers from the 12 universities across Europe, how to bring students and how to bring the industry and business partners of each university to one arena in this case. In any case, our vision or our goal is to create the digital platform which will be the meeting place, collaboration place for the communities of each university in this case. But before we are going to move to this digital collaboration arena, we truly understand that we cannot switch from one level to another level just jumping. It must be a way of evolution. So first of all, we need to increase the mobility of the PhD students, postdoctoral researchers, and even researchers, that each research group at different universities will be familiar, at least personally, face-to-face, know the research and innovation infrastructure, know the research culture, when we could jump to the digital arena. Of course, in the case of pandemics, it's a little bit challenging, but we hope that at the autumn of this year, or maybe at the beginning of next year, we will be able to do that. So from today's point of view, it's very important just face-to-face meeting. For example, here at the conference, we're having the online conference, but you truly understand that face-to-face conference, and especially after meetings after the conference, sometimes they are more fruitful than just only seeing each other on the Zoom.
Thank you.
Okay, thank you. Any questions? If there are no questions, thank you, Lanas, for your presentation. Thank you for all participants in discussion. And now Darius shortly give some remarks for future our plans.
Okay, thanks. So I would like to thank you again for both invited speakers for their presentations and for discussions. And I would like to remind that we are going to have lunch break, not in the hotel, not in the conference place, but it will take 45 minutes, and after that we will have the first session of the presenters, and it will be electronics, and I would like to invite you to join and to discuss as well. And today we have 2 sessions, and tomorrow we have 2 parallel sessions at once, so you can choose which you want and join via Zoom. I would recommend not to watch over YouTube, but to join and to discuss. So let's go to have lunch, and thank you for joining to the conference. Okay.
Dariau, pradedam ar dar laukiam?
Manau, kad pradedam.
Okay. Good afternoon, everyone. I'm glad to see so many participants. And my name is Dangirutas Naikas. I'm professor in Kaunas University of Technology. And today I'm going to be the chairman of this session on electronics. We have 6 presentations. And of course, you know, the time of each presentation is limited to 15 minutes, including discussion and questions. So try to be in time on your presentation. And if we have time left after all presentations, we can make some discussion or answer additional questions if there will be. Audience can ask the questions on the Zoom chat, or those who are watching on the YouTube can write also the questions on YouTube. and we will try to transfer those questions to presenter. And now we will start from presentation from Czech Republic. The presenter is Jaromír Konečný, and the title of presentation is Optimizing of Pure Learning Day-Night Energy Strategy for Solar Harvesting Environmental Wireless Sensor Networks Nodes. So the stage is yours, please.
Everyone. I'm sorry, I click on the close window, so I don't get the last 5 sentences. Okay, I try to start the video right now. So, and I'm gonna share the presentation, right? So the presentation is seen or not?
You should switch to other view. We see, but it's in. You should change the view. Present.
Yeah. I don't know what happened because I have only one mirror screen, and if I start.
Yeah, but it's on the top of the screen. There is selection for those screens.
Okay.
When you start. Now, I cannot understand Czech, I think, but it's наставни изображения on the top. Here you should change. And choose the.
So
now
it's okay right now.
Yeah.
Okay. So hello everyone. Once again, good afternoon from sunny Czech Republic. So I would like to present a paper optimizing of Q-learning day-night energy strategy for solar harvesting environment wireless sensor network nodes. So my name is Jaromír Konečný, and this paper is written with Michal Prauzek. Okay, so something for introduction. So in this paper, we are presenting the follow-up research based on the previous paper that focus to design of a hybrid energy management strategy with Q-learning control during daylight and a linear discharging process at night. We are presenting a method to optimize Q-learning parameters to achieve the best and stable performance results. Okay, so let's switch to environmental wireless sensor node and model and data. We are using an energy harvesting EVSN node model. It contains ARM Cortex microcontroller, solar panel charging module, energy storage, represented by 2 serial connected supercapacitor, and data storage module, and also a low power wireless interface. So basically, you can see the picture of a real hardware, and we are simulating those hardware. We are using 5 years data from Fairview Agriculture Monitoring Station located in Canada, and we are using a data set with solar radiance measured by 5-minute interval continuously from 2008 to 2012. We are using this time interval due to easy quantitative comparison to previous studies. Now something about the Q-learning method. The Q-learning belongs to the group of reinforcement learning methods. The algorithm is suitable candidate which can control an embedded system represented by an VSN node. And it is not very extensive in terms of computer performance. This approach uses properly defined policy, and it could be used to perform an optimal EFSN node management of data collection and wireless transmission. I can say the Q-learning is one of less candidate, because a lot of machine learning methods are dedicated for data processing, and we need to some agent which can plan an actions and control the behavior of some wireless node. The implementation of Q-learning method use Q-table, and basically that is an array stored in memory, and each column represents quantitative values of the actions. The basic idea is to estimate the future reward represented by Q table for performed action A in the state S, and at the same time follow the optimal internal policy. So basically we have some Q table that represents the best action for particular state S. So we have some set of states and set of actions, and we are searching the best action for each state, and the Q table is continuously modified by the reward obtained from the agent. So Q represents estimate of the reward value for the currently performed action A, and there are two coefficients. The first is alpha, that is a learning rate. If alpha is 0, so algorithm use only knowledge gained from the previous steps, and if the algorithm has alpha 1, uses only new knowledge. Basically we are using something in the middle. The R represents learning feedback from a current reward, and the gamma parameter is the discount factor that determines whether the current reward or cumulative reward is preferred. So basically, if gamma is close to 0, so the algorithm preferred instant reward, and if gamma is close to 1, it prefer the cumulative reward. So we are presenting an experiment for day and night algorithm. The key is the day algorithm. So the algorithm for daylight mode is based on the intensity of sunlight over the past 30 minutes. This information can be obtained from the difference between the amount of energy in the supercapacitor, represented by state of an energy storage, and the amount of energy consumed by the EVS node activity. The consumed energy can be also calculated as the energy required for one action times the number of action plus the static consumption of the EVS node. Here we can see the state table. So basically, the state ranges in the solar ratio parameter provide high resolution for very low solar irradiation. So if we have only few sunshine, the systems is in states 1, 2, or 3. For medium resolution, so if we have more sun, the system is in a state 3 to 6, and for high sunlight conditions, so let's say ideal sunlight condition, this we have states 7 to 10, and the state 11 is designed for ideal sunshine condition more than 60% of maximum solar irradiation. So we need to expect what is the maximum solar radiation for our geographic location, and we calculate it in percentage. The daily goal in this experiment is very closely related to reward policy. The reward policy consists with 3 basic parts. The first part's rewards is depend for performing action. The reward strategy considers the need to collect data from the environment by the event node, and the agent receive the highest reward for the shortest operational period. We can say that shortest period means the highest consumption. So we need to find some trade-off between the energy that we can obtain from the environment and the duty cycle, so measuring period. So for action 1 minute, we get a reward 1, and for the interval 30 minutes, we obtain a smaller reward. The second part represents the fulfillment of the charging target. This reaches the maximum value of 1 when the agent fulfills the selected target. When the agent starts overcharging, this reward decreases. The reward value on recharging is limited when recharging by more than 90% of the charging target. In this case, the reward is set to 0.1. So basically, it's about the charging target, the second part of the reward, and we need to obtain an energy during the day for night, because at the night we have no sunshine, and we need to collect some energy in order to measuring in the night. And the last part of the reward is a penalty for lack of energy in the EVSN node. Basically, when the node has no energy and fails, so the microcontroller down and everything down, the algorithm obtain a penalty, and the reward is set to minus 0.5. So basically, this is a penalty for bad action. In the night, as I said, there is no solar energy available. So the policy of control algorithm is set differently than during the daylight period. The device is discharged linearly depending on the current state of the energy storage, then remaining length of the night, and estimated energy required for 1 operational cycle. So basically, at the end of the day, we have some specific amount of energy. We know how the night is long, and we can set the period for measuring, and for the start of the day, we have some small energy for the day start, around 20%. So let's switch to results. Here you can see the 3D graph of total count selected actions during the 30 days in the summer and winter. So the left side is the summer, and the right side is the winter. Maybe I hope my mouse is seen. So the colors means the period. So we try to measure in a lowest period. So that means higher frequency. So 1 minute is the lowest period. So we can see that in the summer we can measure in 1 minute interval, and also during the short night, because in Canada it's a very short night in the summer. And in the right side we can see that in the winter there is no opportunity to measure so fast, so the algorithms choose another states, and during the very long night and very short day, the measuring cycle is around 10 to 30 minutes. Here you can see the typical trend of the summer period and the winter period. The red curve represent state of the energy storage. So basically, the amount of energy in supercapacitor. So during the night is the energy goes down, and during the day there is a very short time to obtain a maximum, and this getting is an overcharge, so this is an unused energy. Also, here you can see the actions chosen by an algorithm, and here you can see the harvested energy. So basically, it reflects the solar irradiance. In the winter is a totally different situation. So I choose some days that was lack of an energy. So you can see that here the algorithm can obtain some energy, but here almost nothing. And this line at the bottom means a failure because there is no energy. In this paper, we also trying to find an optimal settings of alpha and gamma parameters. Note this reminder that alpha 0 means slower learning, alpha 1 fast learning, gamma 0 instant reward, and gamma 1 cumulative reward. Researching about 3 parameters, so we try to maximize thousands of cycles, so maximize number of measuring cycles. We try to minimize failure count, and we try to minimize overcharging count.
Sorry,
so-
Jaromir, the time is.
Oh, I'm sorry.
You can conclude, okay?
I'm sorry. So here you can see only a combination of the 3 graphs. Basically, the best area is near gamma 0 and alpha also 0. So if no time is, so conclusion, you can read in this paper, and I'm so sorry for the delay.
Okay, no problem.
Thank you for your attention.
Thank you. Do we have any questions? I have one question. How the day and night period is selected? Is it real-time clock in the real application, I mean?
Yeah. In the simulation, we are using NOAA calculation, so it's some sort of a lot of sinus cosinus functions, and you can calculate when on a particular location the sun for each day starts and set, and when is the sunrise and when is the sunset. And basically for each location we can produce the lookup table, so the implementation in microcontroller will be very easy.
But microcontroller must have a real-time clock.
Yes, some microcontrollers can have real time. Yeah, must have real-time clock. Yeah,
but and also there could be some problems with synchronization of time. Yes, because if you put microcontroller for 1 year, yeah, without any synchronization, it could the time can be shifted for half an hour or maybe more.
Yeah, maybe this model is based on a little bit older wireless technology, but we are looking for LoRaWAN, and there is also some possibility to transmit data, and receive data, and receive some synchronization and some.
Okay, thank you. If there are no more questions, we can proceed. Thank you, Jaromir. Now we will have presentation from Bulgaria, and the presenter is Ivailo Pandiev, and the topic of presentation: dynamic FPGA-based mixed signal processing circuit for thin film cadmium tellurate lead-free perovskite photodetectors. Please.
Okay, thank you very much. Is it?
We can hear you. We can't hear you.
Something went wrong.
Yeah. But it's showing that he is connected.
Yes. Maybe it is better to go with next presentation.
Yeah, maybe. And okay. and then we can switch to this topic later. Okay, and then we will have a presentation from Thailand. Mi Phu Phin Vai, and the topic is electronically and orthogonally tunable SITO voltage mode multifunctional B-quad filter using LT1228. Oh, Ivailo now is connected, but maybe put your mic on, switch your mic.
Yes, I am.
The internet was lost. The internet connection. I'm ready.
Okay, if you are ready, then we
Yes.
can continue from you.
Yes, I think.
Sorry, me. We will. You will be the next. Again, the same problem. I don't know what's happening.
Is it possible to represent, or other colleague will be?
No, you can represent, but you must share your screen and then.
Okay. I don't understand. Okay. Is it good to visibility?
And switch it to full screen mode. Okay.
And now?
Okay.
Okay, thank you very much, and excuse me for the problem, but the internet was lost. Okay, dear colleagues, my name is Ivailo Pandiev. I'm from the Technical University of Sofia, and now I would like to present to your attention a paper entitled Dynamic FPA-based Mixed Signal Processing Circuit for Thin Film Cadmium Telluride Lead-Free Perovskite Photodetectors. The authors of this paper is Ivailo Pandiev and Maria Alexandru from Department of Electronics and Department of Microelectronics, respectively. The content of this paper include introduction, motivation, and aim of the work. The second one is fabrication of thin film cadmium telluride lead-free perovskite photodetectors. The third one is about design and implementation of FPA-based processing circuit. And here we have results and discussions, and the last one is conclusions. The well-studied cadmium telluride-based solar cell exhibit long-term stability of the electrical characteristic due to their photochemical stability. Unfortunately, the fumes from cadmium telluride usually consist of pinhole, and for their reason, their thickness cannot be decreased to smaller than 4 up to 5 micrometers. In the last few years, growth of interest in organic perovskite-based solar cells have been observed due to their combination of the high efficiency and easy preparation. However, their stability is still an issue, especially as related to the novel lead-free perovskites. What is the aim of our work? In this paper, it's proposed a novel design of photoelectric element implementing lead-free perovskite material in combination with thin cadmium telluride coating with an application in thin film photodetectors. There are some benefits that you can see on the slide with 3 benefits, and of course we have some problems. The problems that have to be overcome are two basic. The first one is lower current generated at the same time, at the same light intensity as compared with the thick non-perovskite material structures. And the second one problem is about the lower value of the internal resistance. This problem and these specific conditions have to be decided during the design of suitable processing circuits. One possible way to realize the processing circuit is by using integrated field programmable analog array with abbreviation FPA based circuit. And they're suitable due to the first one, possibility for dynamic variation of the circuit parameter following the variation of the input, the parameters of the input signal, such as amplitude and noise level. Also, frequency response of the high frequency components as parasitic elements in the signal. And the second one, usage of reconfigurable integrated circuits allow design of fully integrated device without any external discrete passive components. On the right side of this slide are presented the internal structure of the simplified FPA circuit. The basic one element is configurable analog block, and each of these blocks can be configured as amplifier, active filter, comparator, summer, integrator, analog to digital converter, etc. Many of the small signal analog circuits can be realized by using configurable analog blocks. Also, we have interconnection channels that connects the configurable analog blocks each other. And also these channels are using to connect the configurable analog blocks with input and output ports. The programming of this type of monolithic integrated circuit is performed by external digital circuit or by using microcontroller. Also in this configuration, in many cases are used personal computer to create the programming code, or by using a specialized program with graphical user interface. The analysis of the literature shows that it's in the first time of investigation, FPA-based processing circuit integrated with cadmium telluride lead-free perovskite photodetector. In this slide are presented some things about fabrication of this type of photodetectors. On the left side are presented the structure of this device, electronic device, and here is presented the different layers. On the right side are presented some things about it and details about the different layers. And below is presented a small picture that represents the experimental setup for measurement of the optoelectronic characteristics of this device. What about of the design of FPA processing circuit? The input signal is photocurrent, because this electronic component generating photocurrent with specific internal resistance. As an input stage is used transimpedance amplifier or current controlled voltage source, such as operational amplifier with resistors that are connected between inverting input and output. In this slide is presented the basic parameters at low frequencies and also the parameters pole frequency and zero frequency at higher frequency. To stabilize this electronic circuit is necessary to connect additionally feedback capacitor in parallel of the feedback resistor, and as a result is obtained high current, high cutoff frequency or corner frequency that is related basically with operating bandwidth. And below are presented frequency responses for this electronic circuit. After obtaining a voltage proportional to a photocurrent, the output of the amplifier is often connected to low pass filter to eliminate high frequency parasitic components. And then it's transferred to signal sampling circuits. Within the realization with FPA electronic circuit is used analog to digital, can be realized analog to digital converter or voltage to frequency converter. What about of the analog to digital converters? There are two types that can be realized with FPA integrated circuit. The first one is parallel to step data converter, and the second one is successive approximation data converter. For the parallel data converters, we have to use many of the resources of the FPA. And as a result, it's realized successive approximation data converter that use resources only of the one of the configurable analog block. Also, the output signal that are proportional to the input voltage is obtained in series mode, and we are using only 3 wires or 3 pins, from which we can obtain a synchronization signal, data signal, and master clock frequency. These signals are compatible with standard SPI interface that are using for connection between integrated circuits. In some practical applications, the signal process, the successive approximation data converter is not suitable because the resolution is up to 9 bits. As a result, we are realizing the voltage to frequency converter or pulse-wide modulator. As you can see in this slide, here is presented the circuit diagram and the signals from the input and output waveforms. As you can see, the output voltage that are produced from the transimpedance amplifier through all-pass filter is applied to the non-inverting input of the analog comparator, and to the inverting input is applied the sawtooth signal that are produced from the internal quartz stabilized oscillator. And also here is presented some timing diagrams, and of course the output signal where the period of the signal is constant, but the pulse wide is variable according to the comparison between the two input signals. Also in this slide are presented some analytical expressions about the input signals here and about the output signals that can be used to obtain the design methodology to obtain the values of the various parameters of the different blocks according to the parameters of the input signal. Here is presented the implementation of the FPA processing circuit. As you can see, here is presented the external view of the FPA configuration in Anadin Designer program. As you can see, this program we have graphical user interface, and various blocks are presented as symbols. And this graphical user interface is very close to the graphical user interface of the schematic capture from ORCAD PSpice, for example. Also, we have input and output ports where we can to obtain the input and output signals. And in the right side of the window, we can to obtain the information about the used resources and also the power consumption. In this slide are presented the parameters of the configurable analog blocks and their starting values that can be changed during the variation of the input signal, and below are presented the timing diagram of the output signals from analog to digital converter. And the last one is about the input and output stage of the processing circuit. The input stage is transimpedance amplifier, where the transimpedance can be changed during the change of the master clock frequency of the integrated circuit with suitable dividers, frequency dividers. And also we have to see that all signals that are outside and inside of this electronic in this integrated circuit are in differential form. As a result, the noise level are with lower value, because this type of electronic circuits used SZ technology, switch capacitor based technology. The output stage of this processing circuit is realized by differential amplifier, where the output signal is proportional to the is single-ended and is refers to the analog ground, as you can see. Here is presented the transfer function for the low pass frequency, for the low frequencies, and also some parameters about high frequencies also are given the rise time that can be obtained. Figure 8 represents electronic response of the produced photodetectors. As you can see in number A, is presented different light intensities of white light. Number B representing different light colors at the constant light intensity equal to 400 candela per square meters. And in number C are presented the linearity of the photodetector, where we can to see that the non-linearity is not higher than 0.6%. In figure 8 is represented response speed of the produced photodetector at white light with the maximum intensity equal to 400 candela per square meters. In number A are presented general view of the pulses at light to dark transition and vice versa. And in number B and C are represented rise time and fall time during the transition between the two stable state operation. As you can see, the rise time and fall time is not higher than 30 milliseconds. Here is presented external setup of the prototype of the mixed signal processing circuit. As you can see, here is the photodetectors. Here is the PCB board where is realized the differential amplifier and also the FPA electronic circuit and some interface integrated circuit. Also, we have a personal computer that we are using to program the FPA electronic circuit and to obtain the value of the output voltage that is produced from the transimpedance amplifier. Also, the signal in graphical form can be illustrated by using two-channel digital oscilloscope. Below is presented some only two output waveforms on light with intensity around 450 candela per square meters. And the second one is on dark. As you can see, the light of the pulse light is very small and it depends on the offset voltage of the electronic circuit. As a conclusion, in summary, a lead-free perovskite material was introduced to cadmium telluride based photoelectric thin film device for decreasing the absorbing layer thickness by keeping at the same time the performance parameter to levels competitive to the state-of-the-art detectors that use advanced photoelectric materials. The future work of the authors are related to investigation of long-term stability at outdoor conditions and to decrease of the sensitivity area by keeping the values of the performance parameter in the same range. And the last one is related to the acknowledgement. The study was financially supported by Bulgarian National Science Fund under the program for bilateral cooperation between Bulgaria and India that started in 2019. And as a last one, I have to say that full details about this work is published in scientific journal Electronica Electrotechnica, which is open access on volume 27, number 2 from this year. Thank you very much for your attention.
Thank you. So, does anybody has any question? I would like to ask In what kind of application these kind of detectors can be used, applied? For what applications?
Maybe this question can be answered. My colleague Maria Alexandrova, she is also in online.
Okay.
Because she is the central person that produced this type of photo detectors.
Hello. Well, this is actually a conventional photo cell that could be used like any other photo detector for, let's say, darkening conditions and detection motion or moving of objects when the illumination of the ambient is not too high or not too low. I mean, there is a sensitivity even at low illumination, which makes the benefits of this photo detector, making it at the same time thin film photo detector, not like the conventional bulk ones.
Okay, thank you. Any more questions? No, we are in a rush, so thank you, Ivaila. And I already introduced May. Yes.
Thank you very much. Yes, I will stop the share.
Yes, stop the share. And May I please you share your screen and start the presentation, okay?
Okay. Finally, I would like to present the after SID, electronically and orthogonally candidate SID for remote multifunction digraph data using ST122. My name is Lucy Puri. I am PhD student in Missouri in Electrical Engineering, the Faculty of Industrial Education, Kaunas University of Technology, Lagos. Here is my outline of my presentation. I would like to present the background of my research. Active analog data using electronically candidate active reading blocks has mainly focused the research topic area due to its advantages, such as it gives a better judgment than varying the specific element value. Second, it is significant reading block of analog signal processing, automatic control, and implementation systems such as touchstone telephone systems, three-way crossover network, digital derivation, fixed law researches. Next slide, I would like to present the problem. The disconnected or active reading block with different diode commercially IC. First is it cannot provide the separate function at the same time. Second is it cannot provide either electronic or independent candidate. Third is it cannot have process high input impedance or low output impedance. Next is it cannot use grounded capacitor. Sometimes it requires additional circuits such as diverting input or diverting amplifier. This is our research purpose. First is to investigate the effectiveness of proposed circuits. Second is to compare the circuit performance of the proposed circuits with previous work. This is my methodology. There has a lot of disadvantages. First is all grounded capacitor doesn't use. Second is providing separate function at the same time. Third is normal low output impedance doesn't have. Fourth is electronic candidate doesn't provide. Fifth is independent candidate or center frequency and quality factor. This reference citation has voltage differential different amplifier and voltage differential differential input buffer amplifier are constructed from two commercially viable IC, LM13700 and 8800. Voltage differential buffer amplifier is constructed from two commercially viable IC, CA3080 and F356. Four-terminal floating Miller is constructed from two commercially viable ICs, 8844. This is my research methodology. This figure shows the synthesis of multifunction data. It consists of 5 reading blocks, 10 voltage sending circuits, 2 lossless integrator, voltage gain amplifier. It has single input voltage and three output voltage VDD, VHD, VLD. A and B is assigned the time constant of two logic indicators. K is the voltage gain amplifier. The three voltage transfer function VLD, VHD, is obtained in equation 1. From equation 1, the center frequency and quality factor is like this. From equation 2, the quality factor is orthogonally controlled by varying the value of voltage gain amplifier. Moreover, center frequency is linearly adjusted by changing time constant volt indicator. Here is the proposed multifunction figure. This figure consists of 3 LG1228, 4 resistor, and 2 grounded capacitor. Such logic indicator is constructed from first LG1228 and C1. The second logic indicator is constructed from second LG1228 and C2. The voltage gain amplifier is constructed from first LG1228 and resistance R4. The single input VA is applied to semi-or input voltage signal. The semi-or output voltage signal is high VHD, high pass now. The output of such logic indicator is VLD. The output of gain amplifier is VDD. It has the VHD and VDD node provide low output impedance, so it can be directly connected to other circuits without using additional buffer. Here is the low pass function, high pass function, reverse function, and this the center frequency and quality factor is like this. In this equation, the quality factor is orthogonally controlled by varying the ID3. The moreover, center frequency is electronically controlled by varying ID1 and ID2. In this equation, sanity bias is equal to a phi value and capacitor value is equal to same value. So the equation obtained is in this equation, quality factor is independently controlled by varying ID3. The center frequency is linearly and electronically controlled by varying ID. There is a parasitic effect of LC1228 from according to data sheet of LC1228 to get higher operational frequency and to reduce trend resistance effect. Feeder resistor R1 should be low. If operational frequency bandwidth is less than 10 MHz, this parasitic effect are considered and other parasitic effect is ignored. Moreover, if operational frequency bandwidth is less than this, the effect of CYD is also ignored. So the low pass function, high pass function in equation 6. And then the center frequency and quality factor obtained in equation 8. From equation 6 to 8, the parasitic effect of LG1228 affect the performance of proposed circuits, which are operating frequency, center frequency, and quality factor, and gain, voltage gain. Here's the simulation result. The supply voltage are plus or minus 5 volts. Its identifier is 100 microampere. All resistance are 1 kilo ohm. All two grounded capacitor is 2.7 nanofarad. Analyzing equation 5, center frequency and quality factor is like this. This figure shows the magnitude response of BB, LB, HP versus frequency. From this simulation, center frequency and quality factor is like this. So we can calculate percent deviation of quality factor is 1.27% and center frequency is 1.6%. And this figure shows that the bandwidth of low value of R1 is higher than the bandwidth of high value of R1. Because the R1 are 0.2 kilohertz, the operational bandwidth is higher. 5 kilo ohm hertz, operational bandwidth is lower. In our design to achieve higher operational frequency, these feeder resistors are chosen as 1 kilo ohm. This figure shows the transient response of BB feeder function where input or sinusoidal input is 50 millivolts to the linear operating region, and center frequency is 100 kilohertz. And this figure shows the BB response for 3 different ID3 values. For ID3, 123.5 microampere, quality factor is 1.4. For ID3, 185.5 microampere, quality factor is 0.9. For ID3, 371 microampere, quality factor is 0.5. That center frequency is constant 100 kilohertz. So this figure shows that the two can be independently controlled by adjusting ID3. And also this figure shows the center frequency constant, the quality factor is changes for three different values. R4 1 kilo ohm, quality factor is 1.6, R4 2 kilo ohm, quality factor is 0.9, R4 3 kilo ohm, quality factor is 0.6. So it can be independently controlled by varying the value of R4 without affecting center frequency. And also this figure shows the center frequency can be electronically tuned by varying the ID1, ID2 equal to ID. In particular, this decimal of ID1, ID2 are easily implemented by using microcontroller or microcomputer. This figure shows the three devices value input and DC. The input linear rate is 50 millivolts because internet construction of M3128 is BGP OTA. This figure shows the PAC is 1%, lower than 1% when applying voltage 50 millivolts. And this figure shows the multi-tone test and best figure. For three different frequencies, 10 kilohertz, center frequency 100 kilohertz, high frequency 1 megahertz. So attenuation between 10 kilohertz and center frequency is minus 25.52 dB. And also center frequency and high frequency 1 megahertz attenuation is minus 5.82 dB. And also this is the experimental result. This experimental result component value are same as simulation result. So this figure shows the experimental and theoretical value, HPMB dB versus frequency. This simulation has center frequency is 100 kilohertz. Analyzing equation 5, center frequency is calculated value is 102.09, 2 is there 1.732. This figure has applied sinusoidal input voltage is 50 millivolts P2P because to keep the linear rate of LT1228. And also this figure shows transient response of PP figure for three different frequencies. First is 50 kilohertz low frequency, second is center frequency 100 kilohertz, third is high frequency 500 kilohertz. From this figure, low frequency 50 kilohertz, high frequency 500 kilohertz, output signal is attenuated. Thus, the center frequency 100 kilohertz, output and input are same value. This figure shows the center frequency. Without affecting center frequency, 2 is linearly and electronically tuned by ID3. ID3 assigned to 123.5 microampere, 185.5 microampere, 371 microampere. They have the center frequency doesn't change, has two values stay. And also this figure shows that there are three different values, 1 kilo ohm, 2 kilo ohm, 3 kilo ohm. The center frequency is constant, 100 kilohertz. The two value is changes. And also this figure shows the center frequency changes, the two value is constant 1.6. For ID 123.5 microampere, center frequency is located 125.311. For ID 185.5 microampere, center frequency is situated 17.353 microampere. ID 371 microampere, center frequency is located 374.25 kilohertz. So the center frequency can be controlled, which is constant to by simultaneously varying ID1, ID2 value. So this is a comparison and discussion. In my comparison today, there has a lot of configuration. Some are single input, multiple output, other are multiple input, multiple output, and some are multiple input, single output. Some reference constructed from 5LT1228. Some are constructed from differential commercially viable ICs. Some reference doesn't use grounded capacitor. Some reference doesn't provide several functions at the same time. But in my proposal, only provide MBHPDB response, but it is suitable to use in three-way crossover network. In reference number, some reference number, low output impedance does not provide. So it requires buffer amplifier to connect to other circuits. And some has center frequency and quality factor doesn't provide electronic controllability. And some are independent candidates doesn't provide. This is the conclusion slide. It has the 3 triple LT1228, 2 grounded capacitor, 4 resistor, and it can provide and the HPGP response, which is suitable to use in 3-way crossover network. The HPGP response is low output impedance, so it cannot require additional buffer to connect the other circuits. And this provides center frequency and quality factor is independently electronically controlled. Moreover, the quality factor can be controlled by ordering set and K128 without affecting the center frequency. The simulation and experimental results are achieving much with theoretical analysis. The operational from simulation and experimental results, the operational frequency rate is lower than 10 MHz, and then so the harmonic distortion is lower 1% when applying amplitude lower than 50 millivolts. Thank you for your attention. Any questions?
Thank you. So, any questions from the audience?
Maybe I have one.
Okay.
Okay, so how would you suggest to reduce parasitic capacitance at the high frequencies in your proposed filter?
Yes, in my experiment, simulation result, the LG128 capacitance effect at high frequency, so the theoretical experiment is slightly deviated. Please ask me, okay?
The sound quality is terrible. I don't know who understands. Okay, I think we don't have more questions. Thank you. And we continue to the next presentation.
Yes.
Okay, thank you. May you shouldn't share your screen.
Yes.
Okay, and then now we have a presenter from Turkey, Hasan Sisekli, and the topic is a foresee-based electronically tunable current voltage mode third-order quadrature oscillator and B-quadratic filter realization. Please.
Okay. Is everything working?
Yes, perfect.
Okay. Hello to everyone. It is a great pleasure for me to attend this conference and give you a presentation about our paper, which is entitled foresee-based electronically tunable current voltage mode third-order quadrature oscillator and B-quadratic filter realization. My name is Hasan Sisekli. I am from Mustafa Kemal University, Turkey. And my colleague Ahmet Gökçen is from Iskenderun Technical University. Let me start by giving the outlines of my presentation. In the introduction section, I will explain the objective and the prominent features of our study. Then I will give the circuit description of the active element which we used in this study. Its name is second generation current converter and multi-output second generation current converter. In the third section, I will introduce the proposed circuit topology. Then realization of third order quadrature oscillator will be given. And following section is non-ideal analysis. After explaining the simulation results, I will give the outcome of this study in conclusion section. Now let me give some information about the basic concepts of the sinusoidal oscillators. The quadrature oscillators produce two sinusoid signals with 90-degree phase difference in periodic form, and they are commonly used in signal processing applications, telecommunication, measurement, instrumentation, and industrial control systems. And they play an essential role in phase modulators, quadrature mixers, and signal generators. It is affected higher order circuit that exhibit better frequency response, work more accurate, and achieve better distortion performance than the lower order circuits. Therefore, realization of third-order oscillator has been received considerable attention in recent years. Design of quadrature oscillator using passive components, which are all grounded, has always been popular due to its suitability for integration technique and occupying less chip space. Furthermore, a topology which provides both current mode and voltage mode output is a desired feature for dual mode operations. Main features of the proposed oscillator are use of CMOS-based active resistors, which makes the circuit compatible with monolithic integration, and oscillation condition and frequency of oscillation can be controlled independently and also electronically. Availability of both voltage mode and current mode quadrature outputs in the same topology, and capacitors are all grounded, which is a desired feature for integration and beneficial in parasitic capacitance absorption and suitability for low voltage applications. Now let me give you the circuit description of the active element, which is named second generation current conveyor. You see two figures. The top one is about the second generation current conveyor. It has three terminals, which are represented by X, Y, and Z. Operation of the active element can be briefly described as the input voltage of the Y terminal is conveyed to X terminal, and X terminal current is conveyed to Z output terminal. And at the bottom, you see the figure of multi-output second generation current conveyor. The only difference is the number of outputs. We can add extra output by connecting additional output stage to the second generation current conveyor circuit. In equation 1, you see the definition equation of multi-output second generation current conveyor. The input current of Y terminal is equal to 0, and the X terminal voltage is equal to Y terminal voltage. And in the third and following rows, you see the relation between the output currents. Z output current is equal to X terminal current by same sign or the opposite sign. If the sign is positive, it means that X terminal current and Z terminal currents are in same direction. And if the sign is negative, it means that the input and output currents are in opposite direction. Terminal Y exhibits infinite input impedance. That is assumed that no current flows through Y terminal, and terminal Z has very high impedance. It is infinite in the ideal case. In this figure, you see the proposed circuit topology of the quadratic filter. We used two second generation current conveyor, and in the equation number 2, we show the transfer function, voltage transfer function of the filter. From this equation, we can synthesize three filter types, which are called low pass, high pass, and band pass filters. And the combinations of 4 admittance seen in the table, and also the transfer functions and angular frequency formulas are located in the table. The quality factor formula is given in equation 3 at the bottom. And sensitivity analysis has been done by showing you the equations from number from 4 to 9. This equations shows that the passive component sensitivities are less than unity. And now you see the 3 circuits of the filters which are implemented, MOSI implementation of the synthesized filters. the figure A shows the low pass filters, and B is high pass filter, and C is band pass filter. As you see, the resistors, the passive resistors, are replaced by their MOSFET conjugates, and all the capacitors are grounded. Now let me give you some basic concepts of the third order oscillator. In this page, you see the schematic diagram of the third order quadrature oscillator. In this study, we used the principle of second order low pass filter cascade connection by inverting integrator and then forming a feedback connection to obtain a unity gain. And the system loop gain is equal to AS, BS. AS is the gain of the low pass filter, and BS is the gain of the inverting integrator. The Barkhausen criterion tells that if the gain of the low pass filter and the inverting integrator multiplication is equal to unity, the circuit will produce two quadrature signals at a single frequency. It is shown at number 10 equation. Using this schematic diagram, we constitute the third order oscillator, as you see in this figure. The bottom two active elements, number 1 and number 2, are low pass filter, and then we connected the output by the third active element, multi-output current conveyor, as a feedback connection. With this configuration, we obtain 2 voltage outputs and 2 current outputs simultaneously. And in this figure, we show the MOSFET implementation of the third order oscillator. The resistors are replaced by MOSFET conjugates. All of the passive elements are grounded. And as seen from this figure, the oscillation frequency can be electronically tuned by gate voltage of the MOSFETs. Now let's do the circuit analysis of the oscillator. In equation 11, you see the gain of the low pass filter in multiplication by gain of the integrator is equal to unity, and the characteristic equation is shown in equation 12. Frequency of oscillation is calculated as in the equation number 13, and the oscillation condition is shown in equation 14. Into equation from 13 and 14, we can say that R1, R3, and R5 and C5 can control the oscillation condition without interacting the oscillation frequency. And likewise, the oscillation frequency can tune by R2, R4, and C4. The circuit analysis yields us the current transfer function from IO2 to IO1 as given in equation 15. And in sinusoidal state, it is written in equation 16. This equation shows that there is a 90-degree phase difference between the two quadrature outputs. If you calculate the voltage transfer function similarly, we obtain the equation numbered in 17, and in sinusoidal case, it is shown in 18. And this equation shows that the phase difference between two voltage outputs is equal to 90 degrees. Frequency sensitivity against passive components variations is calculated as in equation 19, and it shows that the passive component sensitivities are all lesser than unity. Now let's discuss the non-ideal analysis of the active element. In equation 20, you see the definition equation in non-ideal case. And in ideal case, we assume that current transfer ratio is equal to 1 and voltage transfer ratio is equal to 1. But in non-ideal case, current tracking error and voltage tracking error parameters must be taken into consideration. So in analysis in non-ideal analysis, we will use the equation number 20. If we calculate the voltage transfer for non-ideal case, we obtain the equation given in 21. And the equation that satisfies the oscillation condition, it can be rearranged as given in equation 22. The characteristic equation can be written as you see in equation 23, and radiant frequency is calculated as given in 24. Now we can see that in equation 24 that current tracking error and voltage tracking error parameters don't affect the oscillation frequency, and the condition of oscillation can be written as given in equation 25. This equation shows that in non-ideal case, oscillation condition can still be controlled independently without interacting the oscillation frequency, and the effects of alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3 parameters, it can be minimized by suitable pre-adjustment values of R1, R3, R5, and C5 components. And if we calculate the current transfer and voltage transfer functions in non-ideal case, we obtain the two equations given in 26 and 27. These two equations show that current tracking error and voltage tracking error parameters affect the gain, but not the phase difference between the quadrature outputs of current and voltage outputs. They affect only on the gain. Now let me give you the simulation results. We carried out two simulations for B-quad filter and also for third order.
Could you be more quick to finish your presentation, okay? Because
okay.
Time is
Okay. At the figure, you see the CMOS structure of multi-output second generation current conveyor, which we used in our study. And the MOSFET dimensions, which we used in the study, is located at the top table. And the passive components values are given in the bottom table. Here you see the width and length of the MOSFETs. We used the 0.18 micrometer parameters. And using these values, the center frequency is calculated as 1.59 megahertz, while in simulation it is measured to be as 1.57 megahertz in low-pass filter, and 1.55 megahertz in high-pass filter, and 1.58 megahertz in band-pass filter. The frequency domain responses of the filter are as seen in this figure. And now, here are the simulation results of the third order quadrature oscillator. In the simulation, for the simplicity, we adjusted the resistor values are all equal to 500 ohm, and C2 is 100 picofarad, C4 is 100 picofarad, and C5 is 50 picofarad. Using these values, the oscillation frequency is calculated as 3.18 megahertz, and in simulation, it's measured to be 3.24 megahertz by deviation of 1.88%, and the bias currents are adjusted to 50 microampere in two current conveyors in first two, and 30 microampere in third current conveyor. Now you see the steady state waveform of the voltage outputs at the oscillation frequency of 3.24 megahertz. You see two quadrature outputs. And here is initial state waveform of the voltage outputs, and frequency spectrum figure is at the bottom. The most important feature of this proposed circuit is the electronic tunability. We set to single control voltage, which is shown VC. It is the gate voltage of the all MOSFETs. We adjusted it in the range between 0.6 volt to 0.9 volt. And this figure shows the frequency variation by MOSFET gate voltage. It is adjusted between 2.12 megahertz and between 3.18 megahertz. And this figure shows the steady state waveforms of the current outputs. And amplitudes of current outputs vary between 170 microampere to 282 microampere. The control voltage variation was set to between 0.6 and 0.9 volt. If equal amplitude are needed, an additional automatic gain circuit can be used. In these two figures, you see the variation of voltage output amplitudes and current output amplitudes versus frequency. And these figures show the DHD results for both current mode and voltage mode operations. DHD values remain below 4% for current mode and below 5% for voltage current signals. However, these values can be significantly reduced by using automatic gain control circuit. And this figure shows the Lissajous pattern of the third order oscillator. This figure shows that there is 90-degree phase difference between the two output signals. From this pattern, the measured phase error between two output signals does not exceed 2.5% in the tested frequency range. And the phase error versus oscillation frequency remain below 2.5%. In this figure, you see the variation of the phase error. Now, the conclusions can be briefly as realization of a new electronically enabled MOSFET-based third-order quadrature oscillator and biquadratic filter, which are using all grounded passive components. Synthesizes of voltage mode second-order low-pass, high-pass, and band-pass filters using second-generation current converters, and current voltage mode third-order quadrature oscillator using multi-output second-generation current converter from the proposed topology. Compatibility with integration through foresee implementation and using all grounded components. Low passive component sensitivity in both oscillator and filter circuits. Independent control of condition of oscillation and oscillation frequency. Electronic tuning of the oscillation frequency by MOSFET gate voltage, both in voltage mode and current mode operations. Easy tunability via single control voltage by taking the resistor values equal. As we did in simulation, we used 500 ohms for all resistors. Quadrature phase error with less than 2.5% in an adjustable frequency band about of 1 megahertz. THD below 4% for current outputs and 5% for voltage outputs. And the feature work, topology enhancement to achieve multi-phase oscillator with same advantage of the proposed work.
Okay.
Thank you for listening to me.
Thank you. Could you, if you compare your solution with similar solutions, could you point out the main advantage of your proposed design filter?
Yeah, in the literature, we searched and tested all the similar works, and in the article we put the comparison table. The most important advantage of this study is the circuit can produce both voltage mode and current mode outputs in quadrature mode, and also electronically tunable, and suitability for monolithic integration, and also for suitability for low voltage applications. And another remarkable feature of the circuit is the amplitude of the oscillator is comparatively higher than the similar works. We can say these features. For, yes.
Do you have the plan to make the real micro SIM using that design?
Yeah, we use 0.18 micron CMOS model parameters available for MOSIS.
Mm-hmm. Okay. Thank you.
Thank you for listening to me.
Mm-hmm. Thank you. So.
Hello, Chairman.
Hello.
I am Vinay. So I have one question.
Hi, okay.
I am interested in the frequency tuning. Can your circuit tuning the frequency with the same condition? I mean, you can tune from the 1 kilohertz to 1 megahertz from the same condition. Hello, do you hear me? Can your circuit tune the frequency from 1 kilohertz to maybe to 1 megahertz with the same condition?
Can you answer? Hassan, can you answer or not?
Okay, thank you very much.
Okay, because we are in a rush, so let's continue. And the next presentation will be from Denmark. Jakob Toft will present us the topic analysis of charge pump topologies for high voltage mobile microphone applications. Please.
Yes. Yes, hello, I'm Jakob from the Technical University of Denmark, and I'd like to present my work on analysis of charge pump topologies for high voltage mobile microphone applications. First, I would like to talk about the background for my project and the motivation behind it. Then I want to present the 6 charge pump topologies that are commonly used in the literature for high voltage gain charge pump implementations, and then talk about voltage scaling, dynamic power losses, and settling time of these topologies, and wrap up with a conclusion. So MEMS microphones are used widely in smartphones, laptops, smart assistants, etc. And there is a demand for a higher signal-to-noise ratio from MEMS microphones to improve the performance of stuff like smart assistants, Google Home, Alexa, Siri. And in capacitive sensing microphones, the SNR is given by the sensitivity over the noise. And sensitivity is a function of the bias voltage divided by the air gap times the change in air gap per change in pressure. So using a higher bias voltage increases the sensitivity, which increases the signal-to-noise ratio. So MEMS manufacturer has created a new MEMS structure that requires 180 volts of bias voltage. This must be generated from a supply of 5 volts, and the power consumption should be less than 20 microwatts. And the area should be limited to 1/4 of a square millimeter to fit inside the small microphone packages. So the goal of this work was to determine which charge pump topology is optimal to solve this problem. The generic operation of charge pumps is that you have a floating capacitor and switches that connect the bottom and top plate of the capacitor to different voltages. For example, here in phase 1, the capacitor is charged by V1, and then in phase 2, the capacitor is lifted by V2 to a resulting output voltage of V1 plus V2. When you cascade multiple capacitors, they can be configured in multiple ways, which is the basis of different topologies. There are 6 general charge pump topologies used in literature, where 3 of them is the Dixon, the Pelliconi, and Cockcroft-Walton topologies. And difference can be noted here that the Dixon has the capacitors in parallel, whereas the Cockcroft-Walton is stacking capacitors. The 3 other topologies are the Fibonacci, the Doppler, and the heap topology. And the ideal voltage gain of these 6 topologies are given by this table, where the Dixon, Pelliconi, heap, and Cockcroft-Walton topologies have a linear voltage gain of n plus 1, where n is the number of stages. So a 9-stage charge pump using these topologies would have a voltage gain of 10 volts per volt. The Fibonacci voltage gain follows the Fibonacci number series 2, 3, 5, 8, and so forth. And the Doppler topology doubles the voltage in each stage, so 2, 4, 8, 16, 32. However, in reality, it's not possible to achieve the ideal voltage gain because parasitic capacitances reduce the voltage gain in every stage of a charge pump. From the early example of a generic topology, I've introduced a parasitic capacitance to the top plate of the flying capacitor C pump. And then phase 2, when the capacitor is lifted by V2, the parasitic capacitance is still referenced to ground. So a charge sharing occurs between the 2 capacitors. And the voltage gain is output voltage is now given by V1 plus V2 times C pump over C pump plus C par parasitic. This can also be represented by saying that alpha is equal to C pump over C pump plus C par, and then the resulting output voltage of the topologies changes, where the Dixon and Pelliconi topologies share the same equation of the voltage of the previous stage plus the supply voltage times alpha. The heap topology has voltage gain of the supply voltage plus the voltage of the previous stage times alpha. And the Cockcroft-Walton, Fibonacci, and Doppler topologies all depend only on the voltages of the previous stages. The alpha in some topologies depend on the topology because capacitors are stacked, and when you stack a capacitor, the effective capacitance is reduced. In the heap topology, you charge all the capacitors in parallel, and when you connect them in series, the effective pumping capacitance is reduced. So the parasitic capacitance has a larger impact on the voltage gain. So I use these equations to calculate the voltage gain of area-limited implementations, where I used device parameters extracted from a process design kit of a 180 nanometer SOI process for high voltage electronics. Device parameters like capacitance density of capacitors, parasitic capacitance on source, drain, and gate of transistors, and of anode and cathode of diodes. And then I used devices with the correct voltage rating to implement these different topologies. And as it can be observed, the Fibonacci and Doppler topologies still exhibit a exponential voltage gain and can, with less than 10 stages and a restriction of a quarter square millimeter, reach voltage gains of more than 36 volts per volt, which is required to boost 5 volts to 180 volts. The Dixon and Pelliconi topologies have a linear trend, as seen in the previous table. But the voltage gain of the Cockcroft-Walton and the heap topologies is diminishing and cannot boost the 5 volt voltage to more than up to the required 180 volts. So these 2 topologies, heap and Cockcroft-Walton, are not suitable for the application. In addition to calculating the voltage gain of a quarter square millimeter area, also calculated it for a smaller area to reduce the size of the implementation and see if it was possible. And the Fibonacci and Doppler still have the exponential voltage gain, and they can deliver sufficient voltage gain. And Dixon and Polyconi are also capable of achieving a suitable voltage gain, although the Dixon now requires 41 stages to provide 180 volts at the output. So to further reduce the amount of topologies to consider, I decided to investigate the dynamic power losses based on parasitic capacitances, as the output power of the converter will be very low because the MEMS is a capacitive load, have a low leakage current. So I figured that most of the power losses would come from switching of parasitic capacitances. And the power loss is given by the switching frequency times the parasitic capacitance times the voltage swing squared. And I based my power loss calculations on the 0.04 square millimeter implementations because they're smaller, so they have less parasitic capacitance, which is beneficial in terms of reducing the dynamic power losses. The voltage swings in the topologies are dependent on the topology. The Doppler topology in the last stage has a voltage swing of 90 volts in 2 nodes, A and B, whereas the Fibonacci topology only has voltage swings of 69 volts, and the Dixon and Polyconi topologies only have voltage swings of 5 volts across the entire charge pump implementation. Because the dynamic loss scales with the squared voltage swing, the Polyconi and Dixon were expected to perform better. So for the Dixon and Polyconi topologies, I extracted the parasitic capacitance of the entire charge pump, all 41 stages for the Dixon, and all 36 stages for the Polyconi, for a combined parasitic capacitance of 4 and 4.2 picofarads. And for the Fibonacci and Doppler topologies, I only extracted the parasitics for the high voltage swing nodes. And for different voltage swings, the 5 volt, 5 volt, 69, 90 volts, the Dixon and Polyconi only consume or lose about 10.5 microwatts to switching of parasitic capacitances, where the Fibonacci and Doppler topologies lose 4 to 7 times more, 43 and 73 microwatts. So even though the Fibonacci and Doppler topologies were only evaluated in 2 nodes of the entire charge pump, they use more power than allowed by the MEMS microphone application. So these topologies were also out of consideration for a final implementation due to power losses. Then I decided to look into the settling time, as a fast startup time is beneficial in a smartphone, for example, so you don't have to wait before you start talking. Where I used a switch capacitor converter model, which can be used to model a charge pump, as charge pumps are switched capacitor converters. The model consists of a transformer that represent the voltage gain, the unloaded voltage gain of the charge pump, and an equivalent output resistance, and a load resistance that models the load. For the case of the MEMS microphone, the load resistance is replaced by a capacitor of approximately 10 picofarads, which gives a time constant for an RC circuit of R times C load. And the output resistance is a root sum square of ISSL and IFSL, where ISSL is a resistive component representing the slow switching limit of a switch capacitor converter. And ISSL is inversely proportional to the size of the capacitors and switching frequency. So switching it faster and using larger capacitors reduces ISSL. And the IFSL represent how much the on-resistance of switches used in the switch capacitor converter impact the output resistance. So using larger transistors with a lower on-resistance will lower IFSL. The on-resistance of the Dixon and the Polyconi is different because the Polyconi is implemented using transistors, where there's an inherent level shifter function in the topology. So there will always be a high gate to source voltage, whereas the Dixon topology has a larger voltage stress across devices of 10 volts, which is more than any of the gate source voltage ratings in the process allow. So it has to be implemented using 10 volt diodes. Based on this, I calculated the equivalent output resistance, where in the first iteration just assumed that diodes had the same on resistance as minimum size NMOS transistors. and PMOS transistors extracts have a 37 kilo ohm on resistance. Based on this, the Dixon was evaluated to have an equivalent output resistance of 2.4 gigaohms, and the Pelliconi an equivalent output resistance of 1.6 gigaohms. And given the equivalent output resistance, the settling time, 95% settling time, could be calculated, where the Dixon would have a 73 millisecond settling time and the Pelliconi 49. So in terms of settling time, the Pelliconi topology is performing better than the Dixon. In addition to that, when the charge pump settles near the final voltage, the voltage drop across the diodes would drop further, and at voltage drop of only 0.4 volts across diodes, the on resistance would be 12.7 gigaohms, which would increase the R out significantly and lead to a voltage drop. So more stages would be required to compensate for the low output voltage, which would further increase the output resistance. Alternatively, high voltage transistors and level shifting bootstrapping circuits could be used, but this would increase the parasitic capacitance in each stage of the Dixon implementation, which would require more stages to implement the charge pump that could reach the sufficient voltage gain, and more stages would increase the R as well. So in terms of settling time, the Pelliconi performs better than the Dixon, even if measures where you avoid use of diodes could be implemented. So in conclusion, 6 charge pump topologies were analyzed for a MEMS microphone application where the target was to boost 5 volts to 180 volts. And the implementation was limited to a power consumption of 20 microwatts and an area of 0.25 square millimeters. The Heap and Cockcroft-Walton topologies did not scale well when parasitic capacitances were considered. The voltage gain did not scale well. And the Fibonacci and Doppler topologies consume too much power due to large voltage swings. And the Dixon topology has a long settling time compared to the Pelliconi topology due to the use of diodes, which is an effect of the large voltage stresses in the topology. So based on the analysis, the Pelliconi topology appeared to be the optimal topology to boost 5 volts to 180 volts for the MEMS microphone application, based on the used 180 nanometer SOI process. Thank you.
Okay.
Any questions?
Okay, thank you. So any questions from audience? I don't see any questions. So I would like to ask how these restrictions for area for power consumption were set?
The area is restricted because MEMS microphones are quite small. The footprint of an entire MEMS microphone is usually 2 by 3 millimeters, and that's the outer dimensions. And the inside there's maybe 2 by 1, and half of that is usually used for the MEMS structure. So there's 1 square millimeter for the ASIC that accompany the MEMS structure, and of that ASIC you also need to fit the digital logic and a signal chain. And charge pumps are usually restricted to use no more than 1/4 of that. And in terms of power, there's also power budgets because mobile applications, they want low power consumption. So the lower the power consumption your charge pump can have, the more power you can use in your signal chain to improve the signal to noise ratio of your amplifier and the digital to analog converter. So the objective was in some sense to minimize the area and the power consumption of the charge pump.
Okay, I see. So any questions? No questions. So thank you, Jakob.
Yeah.
And we have 15 minutes left to the next session, so we should rush. And our next presenter is from Serbia, Damian Rankovic, and he will make presentation Argus CNN accelerator based on kernel clustering and resource-aware pruning. So Damian, I ask you to be short as possible, okay? Because we need to close our session till 15:30.
Yes, sure. Do you see my screen?
Yes.
Okay, thank you.
Okay.
So we wanted to optimize accelerator and pruning methods for the convolutional neural network, mainly to to implement it on edge-based devices like small FPGAs. So overview of the presentation. First, we will see just how some basic processing of convolutional layers. Then we will talk about the proposed pruning algorithm for the convolutional neural networks, ideas, benefits, and benchmark. And then we will see briefly the hardware accelerator architecture called Argus with some benchmarks and our architecture of top level, and the main part is convolutional core. So just as a short introduction to 2D convolution, the convolution is done on the input feature map, which is in first layer also of convolutional network. It's just the image, and this can be image in RGB format. And we are convolving this image with kernels, many of them. So what we are actually doing is dot product between, for example, this blue part of the input feature map with the kernel, and that dot product result in one output feature map. So this is a rather computationally very expensive, because there are many layers and many kernels. So some of the networks like VGG16 uses about 15 billion MAC multiply accumulate operations to classify just one image. Of course, there are some more compact today, but this is some extreme example. One way to tackle this complexity is to create good and powerful hardware, but another way can be done using the pruning of CNN. So basically, the pruning in majority of pruning algorithm is done on each kernel differently or filter. So here is the example on the left side how the kernels are pruned. So these gray parameters of kernel are left after pruning, and other ones are zero. So the idea of when we are creating the accelerator is to skip all calculations where we will have zero as a result. So multiplication with zero is zero. So we need to skip all this white stuff. If we are creating the accelerator in regular way, then we need one module which will do this skipping of zeros per each kernel. So this is rather expensive, especially on the FPGAs, to be efficient. So we propose to group similar kernels inside the cluster and to prune them in same way. So we can use only one zero skipping logic per whole cluster. As you can see on picture here, all kernels in cluster are pruned in the same way. Another idea was taken from the previously published work. So let's imagine that this is kernel with 3 times 3 times 64 size. So each of these, we call this stick, can be divided into 8 groups of 8 weights, so 64 in total. The idea of original work is to eliminate 4 parameters or weights from these kernels inside each group of 8 weights. In this case, we will have same computational cost on each of this group, which will balance workload among the processing elements. What we improve here is the analysis on usage of this algorithm on the FPGA. So originally, the zeros, the non-zero values, 4 non-zero values could be on this, and this position, which means 5 different options. So this will actually use 5-to-1 multiplexer, which is expensive on the FPGA, which mainly has 6 input LUT, which is suitable for 4-to-1 multiplexer. So we further constrain this pruning algorithm like this picture. And finally, we combine previous and this one into one pruning algorithm. So we are pruning each group of 8 weights like this, and we are using the clustering to find the most similar kernels to prune them in the same way. In total, this idea saves about two times the used resources on FPGA. And the first idea, if cluster is, for example, 2, we will save two times in terms of zero skipping logic. We did pruning on MobileNet, ResNet 50, and VGG because these are 3 different CNNs. And here are the results. These are the results of unpruned network, and these are accuracies, top 5 accuracy after pruning. So we can see that this is that we have small loss, but the loss is pretty much very small, and the application on which we did pruning on ImageNet is a rather hard task for edge-based computing. Here is the top level of this configurable accelerator. Mainly it has 2 cores. It has convolutional core and the dense layer processing core, which is used for other layers. This processing of other layers is not that important in terms of time, so we will see more detailed explanation of this convolutional core. Beside the convolutional core, there are some data move engines which are connected directly to the DRAM through XI full interfaces. The number of convolutional cores and DLP cores is configurable, so we can choose based on the complexity of the process network. Here is the convolutional core in more details. There is register file for the configuration. There is a DRAM arbiter. There is also input stream, which is actually used as a cache buffer. There is a link. A link is used for stacking more convolutional cores, and the main part of this convolutional core is processing element array. Processing element array contains FSM for controlling. It has the memory bank that stores weights and non-zero indexes. It has input feature map point selectors, which are actually zero skipped logic, and inside these there are actually 4 4-to-1 multiplexers. There are 32 processing elements, which has 2 DSPs on, and they are clocked at 500 megahertz on the FPGA. And at the end, there is a result collector, which collects result in round-robin manner from these processing elements and does the rounding and the activation function on these results. Here are some benchmarks to the sum with the sum of the previously published works. As you can see, frame rates on the AlexNet for convolutional part only is comparable to the other and better than some. Full network is better than just the NVIDIA solution, but this is due to the very big fully connected layers at the outputs, which are currently, let's say, obsolete. On the other hand, we have a very favorable comparison with using VGG 16. In terms of performance, the core has the best among these presented here. And what is actually the power of this core is the utilization of hardware. So if compared to the other FPGA solutions, we can see that Argus uses at least twice time less LUTs, and one of the smallest number of the MAC units, which are actually the DSP blocks. So the whole benefits of the core is possibility to be fitted inside the edge and small, let's say, small FPGA devices, and to have comparable performance with the others. In terms of mobile net, we can see that we have a little bit lower performance in terms of frames per second compared to the accelerator that is optimized especially for the depth-wise convolutions. But on the other hand, we can see that this solution, which is better in terms of frame rate, has almost has more than 10 times more DSP blocks inside the accelerator. So this cannot be fitted on the edge-based computing. And here is another benchmark. You can find these references in the work. We did a comparison in terms of giga operation per second per use DSP, per use LUT, and per use BRAM. As can be seen, the Argus has the best density among these accelerators in terms of giga operation per DSP. It's not the best in terms of giga operation per LUT, but it's not that big difference. And in terms of giga operation per use BRAM, on the FPGA device, it has at least twice better performance density. At the end, I would like to conclude what is done in this work. So we proposed the novel CNN pruning algorithm, introduce the kernel clustering, which will reduce the zero skipping logic utilization by factor of 2. We enhance the previously published pruning algorithm, and we tailor it especially for the FPGAs. And at the end, we proposed the architecture called Argus. This is complete CNN hardware accelerator, which is able to prune to process the dense and sparse CNNs pruned by these algorithms. And we can see that it has a balanced utilization of available resources on modern FPGAs. So it enables usage of this of Argus on the cost-effective FPGA devices.
Thank you. So questions? I will ask one question. For what kind of application your accelerator is designed to be used?
Yes, actually, this can be used in industry. What I saw is that some kind of similar accelerators are used to classify fruits, to classify damage bottles and stuff like that. Yes, in industry mainly for today.
For image processing, yeah?
Yes, yes, sure.
Mm-hmm. Okay, thank you.
Thank you.
So if we don't have more questions, let me finish the session. We exceeded our time exactly half an hour, and now it's time for next session on power electronics. And thank you for all participants, for all audience, and good luck.
Okay, thank you. We can wait around 1 minute until next chair will connect. Probably he has some technical issues.
Do you hear me, dear Darius?
He is alive.
Do you hear me?
Yes, yes.
Hey, hi. I had a problem with time zone now. I forgot. I looked at my hour and we are 1 hour, how to say, shifted compared to Lithuania. So sorry for that. I was prepared, but just.
Okay.
But I hope I'm here.
Okay, so your session is already started, so you can introduce yourself and probably start.
Right now.
Yes, right now.
Okay.
Okay,
Thank
good
you.
luck.
Thank you, dear Darius. Hi, and good day to everybody. My name is Dardan, and I will chair today's session on power electronics. I'm with the University of Pristina in Kosovska Mitrovica, and it will be my pleasure to share this time with you. The first presenter for today comes from Bulgaria, and he is Professor Nikolai Hinov. I hope he is here. And
hello, I will present instead of Mr. Hinov. I am the co-author of this paper.
Okay, you're welcome. You will the first paper in this session today is practical approach for improving the dynamics of the resonant DC-DC converter. Please take your time and present your work.
Okay, I will share the screen. Do you hear me good?
Yeah, of course.
Okay. So now can you see the presentation?
Yeah, presentation is shared.
Okay, so I will start it. So my name is Tveti Hranov, and I will present the tolerance analysis of common transistor DC-DC converters. I am co-authoring this paper with my colleague Nikolai Hinov. Brief introduction. Tolerance analysis is made on the most widespread converters. This is the buck boost and buck boost converters. And the idea is to observe the change of the parameters of the reactive elements upon the state variables, that is the current to the inductance and the output voltage. The results are obtained, which are visualized as characteristic and presented on 3D graphs. And this study is interesting in view of the operation guarantee of the performance of power electronic devices. So this is the study. We have a common mostly output parameters such as output voltage, output current. We are using the same duty cycle, operating frequency, 300 kilohertz, and the filter elements are the same with the given tolerances. For the inductance, this is plus minus 20% and for the capacitor, this is plus minus 10%. So in order to obtain the comparable results, the operation of the converters are maximum the same. This is achieved using the following input voltages. For the buck converter, this is 40 volts. For the boost, it is 10 volts. And for the buck boost, it is 20 volts. And initially, the results were obtained for the influence of the tolerances in the steady state and then on the transient and dynamic processes. So these are the results for the buck converter. Here can be seen the inductor values, that is plus minus 20%, and the capacitor values plus minus 10%. And this is how the average RMS inductor to the inductance of the converter is changing. Same here for the maximum capacitor voltage from the tolerances. The next slide shows this for the boost converter. As you can see, the graphs are a little bit different, but the idea is the same to see how the tolerances are affecting on the steady state. And here is the buck boost converter tolerance analysis. again, it can be seen how the tolerances of the circuit elements are affecting the steady state operation of the inductor current and the capacitor voltage. And here are the results for the transient processes. First, again, for the buck converter with the inductor current and output voltage at different pairs of inductance and capacitance. This is the nominal regime here, purple. Here is for the boost converter. And lastly, for the buck boost converter, of course, the output voltage is inverted because this is an inverting topology. And I can summarize the results with the following statements. The change of the operating mode due to the tolerances of the filter elements is insignificant in steady state mode, but on the other hand, the transient process is significant and different in the different topologies. And due to the nature of the operation of these converters, serious attention should be paid to the synthesis and control of the the setting of the control in order to achieve improved characteristics and guarantee the output performance, like systems for soft starts and others. The manuscript presents a model-based approach for tolerance analysis of the most common used basic power circuits. This is a good approach for the design to evaluate the values of the circuit elements and parameters of the operating modes, what changes can be expected in them due to tolerances, and how to make optimal selection of elements by various complex indicators such as price, quality, reliability, etc. And the achieved results are useful for improving the practical training and studying in the converters in general. This project is supported by the European Regional Development Fund with the Operational Program Science and Education for Smart Growth in the National Center of Mechatronics and Clean Technologies in Bulgaria. Thank you very much for your attention.
Thank you very much, dear colleague Hranov, for your presentation. As I can see, chat is currently empty. We do not have question. Any question for Mr. Hranov from other participants? Okay. You will have just one question from me.
Okay.
I read this paper in meanwhile, and just about applicability of it. Did you apply this DC-DC converter somewhere in practice?
Yes, we have made some studies using real converters, and yes, we obtained similar results. However, we will continue to do experiments with different manufacturers of inductances and capacitors in order to obtain more practical data and compare it with the theoretical results that we achieve.
Because in the title and in a few places in the paper you wrote the improving of the dynamics of the resonance. You mean you improve the performances, how to say, during the operating time, or somewhat different?
At the design stage.
Design stage.
Yes.
Because this kind of title and topic is very rare to have improve of dynamics. What is just one question about that? I have no more questions. Thank you.
Okay, thank you.
The next presenter comes from Slovakia, and the title of paper is Design of a Wireless Charging System for Inductor. and this paper will be presented by Michal Frivaldsky. Are you here, dear colleague? I will repeat my call.
Probably he is not.
He's not here.
Yes.
Maybe time zone, like in my case, because always we are thinking about the Central European time, and I was already prepared nearby the computer, but
Okay. Okay, maybe he will join later, so he will make presentation after all.
Yeah, we will give the opportunity to the next presenter to take this time. Next paper is a 5 volt to 180 volt charge pump for capacitive loads in a 180 nanometers SOI process. This paper will be presented by Jakob K. Toft. Mr. Toft comes from Denmark. Are you here, dear colleague?
Yes, I am.
You're welcome. Take your time and present your paper. We have, I think, enough time. For each paper is 15 minutes reserved, but you saw for the first presenter was so quick.
Yes.
Welcome.
Thank you. Yes, so this is some work that is built upon the previous presentation I gave on optimal topologies for the same application. And again, I would like to start by introducing the background for my project, the use charge pump topology. I see I haven't gotten this updated. Embarrassing. I will just continue. So again, it's a MEMS microphone application where the sensitivity is given by the bias voltage over the air gap times the change in air gap per change in pressure. And the application is still the MEMS microphone where the power consumption is limited to 20 microwatts. There is limit has increased to 0.5 square millimeter due to some supporting circuits that will be introduced later. And the clock frequency of the circuit has to be at least 100 kilohertz or above to reduce the risk of interference with the audio measurements. And rise time must be less than 10 milliseconds. And the load is a MEMS structure that has a capacitance of 10 picofarads and a leakage of 2 nanoamperes at 180 volts. So in the previous presentation, the study showed that the Pelliconi topology was optimal to reach this 180 volts from a 5 volt supply using a little area and little power. However, in this work, I've used an extension to the Pelliconi topology where the transistors in this diagram M5, M6, and the capacitor C bulk has been added to stabilize the bulk voltage of M3 and M4, as that leads to some problems in the traditional Pelliconi topology when you scale it with a lot of cascaded stages. So the voltage gain is given by the voltage supply times the voltage supply plus the number of stages times alpha, where alpha is the ratio of pumping capacitance to pumping capacitance plus the parasitic capacitance, where C pump corresponds to the capacitance of C1 and C2, and parasitic capacitances are the parasitic capacitance on the top plate of the capacitors, this node and this node. And the voltage gain can be maximized by maximizing the pumping capacitance or minimizing the parasitic capacitance, where maximizing the pump capacitance requires a lot of area because you need to use larger transistors, and this works against the target of having a small charge pump. And minimizing C parasitic requires that the topology is kept simple and utilize small transistors, which is what this topology has achieved in terms of optimal. So On a system level, the entire system consists of a clock generator that generate the clocks A and B for the charge pump, high voltage ESD protection because we have 180 volts here, and then an output filter to remove noise from the generated bias voltage before the bias voltage is put on connected to the MEMS. The clock generator is based on a structure known from non-overlapping clock generators, but in this implementation, the delay chains are sized to create a crossing clock, where the clocks A and B, they cross the mid supply. This reduces the amount of reverse currents that are in the topology. Normally in literature, people refer to using a non-overlapping clock, but using a non-overlapping clock results in a lower voltage gain. The charge pump itself was designed to minimize the size of the pumping capacitors to maximize the voltage gain and minimize the parasitic capacitance of transistors and layout, and to compensate the reduced voltage gain by adding additional stages. So I implemented two variants, a variant where 75 femtofarad capacitor was used for C1 and C2, which required 57 cascaded stages. 75 femtofarads was the minimal feasible pumping capacitance, and the capacitance below this had diminishing returns in terms of area. And then I implemented the 300 femtofarad variant, which only required 46 stages to reach 180 volts from the 5 volt supply. And that was implemented to have something to compare the minimum size implementation with. All the transistors were implemented using minimum size transistors as the on-resistance was low enough, and using minimum size reduced the parasitic capacitance and maximized the voltage gain. And then layout, a significant amount of area was spent on spacing wires and capacitors to further reduce the amount of parasitic capacitance. The output filter is implemented as two RC filters, where the resistance is implemented as a diode-coupled PMOS transistor, because as the voltage settles, the voltage drop across the transistor is very low, and the impedance become very high. The cross-coupled diodes are used for ESD purposes. So a ESD discharge can go through the diodes that are larger than the transistor. And the ESD protection itself is implemented using stacked PMOS transistors, and is based on blocks provided by the design kit. And I implemented 3 different versions of ESD to investigate the impact of leakage through the ESD. One version has leakage of 10 picoamperes at a voltage of 210 volts on the high voltage node. Another version has a leakage of 10 picoamperes at a voltage of 285 volts. And then I also implemented a version of a charge pump where no ESD was used, which is risky, but that way leakage through the ESD structure is eliminated. The physical implementation was fabricated in a 180 nanometer SOI process with a 200 volt breakdown voltage from transistors down to the substrate, which is implemented by using buried oxide and deep trench insulation. The transistors used for the charge pump itself is only rated for 5 volts, but the breakdown voltage down to substrate is 200 volts. Yep. The physical area of the different variants and ESD versions is listed in this table, where the 300 femtofarad charge pump is a little more than twice as big as the 75 femtofarad charge pump, while the charge pump is only the cascaded stages and the clock generator. The ESD area is significant with 0.1 square millimeter approximately, and the output filter is even larger with almost 0.15 square millimeters. So both the filter and ESD contribute significantly to the total area of the charge pump implementations. Only one implementation could not fit on 0.5 square millimeters, the 300 femtofarad version with the large ESD structure. But all of the others fulfilled the requirement of fitting on less than half a square millimeter. To measure the charge pumps, I used a source meter to set the load to a fixed 2 nanoamperes for uniform measurements, and I used an amplifier with a very low input bias current to buffer the output for oscilloscope measurements, such that the instruments did not load the charge pump in any significant way. The buffer has a input bias current of 250 femtoampere, so significantly less than the 2 nanoampere synced by the source meter. So the output voltage and power consumption of the different charge pump variants and ESD versions is listed in this table, and all implementations managed to reach above 180 volts from the 5-volt supply when they're clocked by a 2 megahertz clock. The power consumption on the other hand, though, is significantly more than the 20 microwatts that was the target, where the 75 femtofarad version consume 330 microwatts, and the 300 femtofarad version consume 620 microwatts. Comparing the two charge pump variants with simulation results revealed that the 300 femtofarad charge pump is less sensitive to parasitics compared to the 75 femtofarad charge pump, as expected. When simulations are run without the parasitic extraction, the output voltage difference for the 300 femtofarad version is only 20%, whereas it for the 75 femtofarad charge pump is 30%. So the 75 femtofarad variant is more sensitive to parasitic capacitances than the 300 femtofarad variant. Looking at the output, the power delivery capability of the two charge pumps, it can be observed that the 300 femtofarad variant can supply almost 3 times as much power as the 75 femtofarad version, 80 microwatts versus 240 microwatts. But even though the 300 femtofarad charge pump can deliver more power, it cannot reach a higher output voltage than the 75 femtofarad charge pump. So the problem is not about delivering power to the load, but about parasitic capacitances, reducing the voltage gain of the charge pumps. Rise time of the two variants, when clocked at 1 megahertz, the 75 femtofarad variant doesn't rise fast enough. When clocked at 2 megahertz, it does. Which is perfect, except at this clock frequency, the power consumption is way too large with 300 microwatts for the 75 femtofarad version. But reducing the clock frequency reduces the power consumption, but unfortunately also affects the output voltage of the 75 femtofarad version. For the 300 femtofarad version, the clock frequency can be reduced to 100 kilohertz, and it still can output more than 180 volts, whereas the 75 femtofarad version drops down to 178.5 volts. But running the 75 femtofarad version at 100 kilohertz reduces the power consumption to just above 20 microwatts. So one approach to operating charge pump could be to use 2 megahertz clock during startup to achieve the short rise time, and then reduce the clock frequency after reaching 180 volts to save power. Comparing with the prior art, the implementations of this work there are charge pumps in prior art that have a higher voltage gain and higher output voltage, but they also have an area that is 200 times larger than the charge pumps implemented in this work. And the second highest output voltage in literature does not reach 180 volts, while still consuming more than 40 times the area of these charge pumps of this work. So the developed charge pumps is reaching a goal that no prior art has reached, but the application is also different than for what prior art has sought to achieve. So in conclusion, with regard to the design target, the implementations got close. The 75 femtofarad variant area was less than half a square millimeter. And at a clock frequency of 2 megahertz, both charge pumps had a rise time of less than 10 milliseconds. but the power consumption at 2 megahertz was much higher than the target of 20 microwatts. But lowering the clock frequency after having reached 180 volts during startup could reduce the power consumption to 40 microwatts for the 300 femtofarad version and 20 microwatts for the 75 femtofarad version. So, in short, the two charge pump variants illustrated the impact of parasitic capacitances, as the larger pump capacitance required fewer stages to reach 180 volts, and the 300 femtofarad variant was less impacted by parasitics when comparing simulations and measurements. And although the 75 femtofarad charge pump variant has a lower voltage gain per stage, it used less area and consumed less power than the 300 femtofarad variant. Often in the literature, people are talking about maximizing the voltage gain per stage, but this that would not have been a suitable design approach for this application. So for this application, in terms of both power and area, the best approach was not to maximize the voltage gain, but to compensate by adding additional stages. So, thank you.
This is also my question. The dear participants, do you have any question for Mr. Toft related to this good presentation? It seems you will stay without questions from colleagues. But I will say a few words about your work. Work is good, supported by experiments. You presented it is in the best possible way. And thank you for this very nice presentation, dear colleague Toft.
Thank you.
The next, you're welcome. The next presenter comes from China.
Excuse me, good afternoon. My name is Jakub Kovaga and I came to replace Michal Trivalski.
Okay, the second paper, author of the second paper in this session. You are here?
Yes.
Okay, welcome.
Thank you.
Now it will be my pleasure to introduce colleague Jakub Kovaga.
Yes.
And he will present the paper Design of a Wireless Charging System for e-Scooter. The author comes from Slovakia and will present now his work. Welcome, please, take your time.
Thank you. Okay, so hello to everyone. My name is Jakub Škorvaga and my presentation deals with the design of wireless charging system for e-scooter. The aim of this research was to design and construction wireless charging system for electric scooter. This research was created as a cooperation with my colleagues Michal Trivalski and Miroslav Pavelek. This research included the design and construction of couplers for the implementation of wireless power transmission and also the choice of the suitable power electronics topology. The motivation of this research was the removal of disadvantages associated with using of standard charging module, for example, risk of water interaction, connector oxidation, and low charging power and long charging time. Our proposed system is designed for, our proposed system is designed for e-scooter Xiaomi Mi 365, which is a very popular e-scooter on the market. This e-scooter contains a lithium-ion battery with a capacity of 7.8 amp hours and consists of 30 cells. The voltage of one cell is 3.6 volts, and the commercially available charging module has a power of 71 watts and an output voltage of 42 volts, while it is able to supply a current of 1.7 amps, and it takes 5 hours to charge the battery with this commercial adapter. Design of coupling elements. For design of couplers, we use software designed for design of wireless charging systems. First, for a successful calculation, it was necessary to enter the input parameters into the graphical interface of the software. These parameters include output power, load volume, required efficiency, transmission distance, and also nominal switching frequency. In this slide, we can see a simulated curve of the coupling coefficient depending on the distance of the coupling coils. Below this curve are calculated values of the coils, compensation capacitors, and also the values of the parasitic resistances of coils required for transmission of 200 watts power. Next, we adapted the shape of the coil to the shape of the base of e-scooter, and it is an oval coil inserted in a rectangular plate. The board is complemented by ferrite shielding, which increases inductance, and the simulated inductance value in the console program was 92.6 microhenry. With the use of designed frame console model, the evaluation of the magnetic radiated field according to standards was realized, and the operation was considered for nominal power 200 watts, while the distance between coupling coils was set to 50 millimeters. And in the picture, we can see the distribution of magnetic field within the proposed wireless charging system, where border of the amplitude is set to 27 microtesla, what is maximum exposure limit defined by international standards. From the simulation, you see that the magnetic induction drops below the limit approximately 0.2 meters from the system within radial or axial direction. The designed model is made using a 3D printer. The experimental model consists of 17 turns. The length of the board is 42 centimeters. The width of the board is 14 centimeters, and with ferrite shielding, the measured inductance value of the model was 91.6 microhenry. Implementation of compensation capacitors. The value of the capacitance of the compensation capacitor was obtained on the basis of the Thomson relation. The capacitor consists of 14 series pairs connected in parallel, and the resulting capacitance of the compensation capacitor was 39.2 nanofarads. Sorry, in the picture, you can see the experimental model. Power electronics concept for proposed e-scooter system, charging system. The wireless transfer is realized here with a reduced voltage, while secondary side uses a high frequency, low voltage Schottky rectifier, followed by buck type of DC-DC converter, operated with constant voltage and constant current charging mode. The concept contains up to 7 subsystems, which make it a more complex system in terms of the number of components. But on the other side, the charging control algorithm is much simpler. following converters was calculated and designed in this manuscript. So included power factor corrector, primary side DC-DC buck converter for reducing input voltage, full bridge inverter, and secondary side rectifier, and also the secondary side DC-DC buck converter for charging battery module. The picture, we can see the experimental model of voltage inverter. Experimental verification of the functionality of the proposed solution was performed by laboratory measurement. The measurement to obtain the dependence of efficiency on the size of transmitted power was performed for 3 different mutual distances. In the picture, we can see the laboratory measure setup. Here we can see the results for measurement of efficiency. At the distance 5 centimeters, the maximum efficiency of 92.5% was achieved at the power 160 watts. At the distance of 6 centimeters, the maximum efficiency was achieved at 81% at the power of 125 watts, and the highest efficiency at the distance of 7 centimeters was 80% at an output power of 2 watts. The table in the second part of the laboratory measurements, focus was given on the investigation of efficiency and voltage gain characteristic depend on the operational frequency. The measurement was performed for a total 16 switching frequencies. The range from 70 kilohertz to 105 kilohertz. And the highest efficiency, 99.5%, was coupling coil was achieved at the distance 50 millimeters and frequency of 95.5 kilohertz. Simultaneously, at this point, high voltage gain is achieved. At the 60 millimeters, the maximum efficiency was 85% at the frequency of 90 kilohertz, and the value of the voltage gain also reaches its maximum. At 70 millimeters of distance, the efficiency of 90% was achieved at a frequency 87.6 kilohertz, and here the voltage gain is not reaching its maximum, but opposite to previous situations, it is a little bit higher, thus enabling to transfer more power, but for the sake of the reduced efficiency. And conclusion, in this research, we managed to achieve the goals summarized in the points. So choice of the power electronics topology and design of power converters, proposal of coupling coils with respect to the dimension of the scooter, construction of physical model coupling coils and capacitors, and also power converters, and experimental verification of the proposed solution by laboratory measurement. Thank you for your attention.
Dear colleague Škorvaga, thank you very much for your presentation, and it was very interesting. And dear colleagues, do you have any question for Mr. Škorvaga? It seems and chat box is empty. We do not have questions from colleagues, but I will ask you a couple of questions. For example, I read the paper and I didn't saw any real photo of this e-scooter. What is e-scooter? Do you have any photograph of it?
No, so far we just make tests on the converters in laboratory without the e-scooter. So maybe in the future we can try to make some tests on the real e-scooter.
Because it's always interesting not to see just research results and some practical devices to have in paper. And the second question is, do you think about power to develop a charging system of higher power?
I don't know if the battery are able to receive more power, because we were limited by charging current of the battery pack of the e-scooter. So maybe when we use batteries with higher charging current, we also can try to charging with higher power.
You said in your paper that, how to say, your technology of charging, wireless charging is very well known, but I still have my laptop and phones charging in traditional way by a cable and adapter. Okay, Mr. Škorvaga, thank you very much for this nice presentation.
Thank you.
And sharing your research results with us. The next presenter comes from China. Shuaibu Musa Adam will present the paper soft modeling of photovoltaic modules based on MATLAB Simulink. Are you here, Mr. Musa Adam?
Previously it was connected, but yes, it is.
Yeah.
But do not react.
Cannot find. Oh yeah, I see him here. Do you hear us, dear colleague Adam?
Maybe we can go with next one. Okay, maybe he will.
Hello.
You are here. Welcome,
Yes,
please.
I'm here.
Take your opportunity to present your work, and in next 15 minutes, present your research results. Are you here, Mr. Adam?
Yes, I'm here, sir.
Share, please, your screen and
okay.
Start presentation.
Hello.
Yeah,
can you see my screen?
Yeah, we see it.
Okay. Good evening, all distinguished guests present. I am Shuaibu Musa Adam, presenting our collaborative research study on the topic soft modeling of the photovoltaic modules based on MATLAB Simulink. The presentation is going to be made based on the following outline. So, introduction, motivation for the study. A large volume of PV panels modeling technique exists in the literature. However, majority of the technique use some arbitrary or assumed values of the IV equation parameters, which constantly affects the accuracy of the overall parameters estimation. And the effect is more prominent in methods which employ iterative approaches due to sensitivity of the initial guess values, which consequently affects or leads to the convergence problems for the models modeling. As such, the current study focused on using MATLAB programming to implement the PV modules in the MATLAB Simulink. The proposed algorithm in this study uses the manufacturer's datasheet information to implement a 5-parameter single diode model of the PV module. As you can see in figure 1, it's shown the circuit, the equivalent circuit of the single diode PV model of the PV module device used for the implementation of the algorithm. Why the single diode model? The single diode model was used because of its easy implementation, fast convergence, less complexity, as well as its suitability for majority of the circuit simulators. Now, the mathematical model of the single diode model PV device used. As you can see, equations 1 to 4 show the AB equation parameter from the basic theory of semiconductor. In figure 2, you can see the IB curve characteristic of the PV device at standard test conditions. On this figure, you can see 3 highlighted critical or important points on this curve, which are ISC, the short circuit current, VOC, the open circuit voltage, and the MPP, that is the maximum power points of the IB curve characteristics. Now, the manufacturer's datasheet information. In this study, 3 model manufacturers or 3 different types of PV modules were used to test the proposed algorithm. And these are the datasheet information for these 3 tested PV modules, which are all from the crystalline silicon family. Now, the methodology. The methodology for this research study was categorized into 2. 1, the IB equation parameters were derived. Secondly, the derived parameters were used or were implemented in the MATLAB M-file script in order to test the proposed algorithm. As you can see, the 5 unknown parameters, which are the light generated current, the reverse saturation current, the diode ideality factor, the series and shunt resistances of the PV modules were derived using equations 5 to 8. Now, the methodology. After the parameters were derived as shown in the previous slide, they were implemented using the M-file script as shown in this iterative algorithm flowchart. Newton-Raphson technique was used for the algorithm implementation, as you can see. Similarly, a Simulink model of the proposed algorithm was also developed in the Simulink environment of the MATLAB, in which all the 5 IB equations parameters were also designed and implemented, similar to the one shown in the M-file scripts in the previous slide. Now, as you can see on this screen, it shows the PV model subsystem of the Simulink model. This subsystem can be used to test any of the PV model in which the 5 unknown parameters were derived. So this shows an improved Simulink model for the SolarX MSX60 PV model. Now, the results and analysis. It can be seen from tables 4, 5, and 6 on the next slide that the implemented model correctly matched with the experimental data obtained by the manufacturers at STC based on the analyzed parameters. On table 4, you can see some highlighted values of the maximum power P max E and the maximum power P max M. The maximum power P max E shows the maximum power obtained by the model parameters, that is the experimental maximum power. Meanwhile, the P max M indicated the maximum power obtained after the proposed algorithm has been run. It can be seen that these values correctly match with the one obtained by the model manufacturers. Figure 6 also shows the adjusted parameters, the result obtained for the adjusted parameters of Solaris MSX60 PV modules at STC. Similarly, the Pmax E and the Pmax M coincided. Meanwhile, the values of the light generated current IL has also been bolded, which also is similar to the values of the short circuit current ISC. So in this study, you can see that the IL and the ISC are not exactly the same, which disproved the previous assumption by researchers that the short circuit current and the light generated current at STC are exactly the same. However, on this study, we found out that they are entirely different. It can be seen from table 7 that the diode ideality factor were compared for the 3 tested models, which can be a comparison of this ideality factor shows that the values differ from one another, despite that the models are all from the same family group, which clearly shows an improvement in the previous researchers, in which they assumed the value of the diode ideality factor to be exactly the same. It can also be seen from table 8 that the modeling algorithm yielded accurate results as expected, with crystalline silicon CHSM P220 having the best match values with the least power error measurements. Now, the compared IB curves for the Solaris MSX60 module. The solid blue lines in the graph indicated the experimental output, while the dashed red lines represent the adjusted parameters output. As can be seen, the IB curve from figure 6 and the PB curve from figure 7 of the adjusted and the experimental data successfully coincided at the 3 critical points of these curves for the Solaris MSX60 module and all other tested models for this study. Now, the continuations of the results. Model validations. The proposed algorithm has also been validated by testing this algorithm at different irradiance and temperature. As you can see, figure 8 shows the values of for the Solaris MSX60 PB module at selected irradiance, while figure 9 shows the value of the same PB model at selected temperature. The results obtained clearly show an improvement of the result obtained by some previous researchers as cited here, using the same PB model but with different modeling approach. Those validate the proposed modeling technique performance at conditions different from the STC. Now, conclusions. The proposed algorithm used manufacturers' datasheet information to implement the single diode PB model, in which the use of arbitrary values of some of the IB equation parameters were dismissed or were abolished. However, the algorithm proposed Meanwhile, the algorithm proposed meets the key features of minimal or negligible differences between the model and the actual measurement data, most especially at the maximum power points, while exhibiting a fast convergence. It has also proved to have improved the result obtained by previous study using similar approach, but with different initial guess values. Now, prospects for future work or for future studies. The validation of the proposed modeling technique using the real outdoor experimental data is beyond the scope of the current study. As such, it is suggested that it should be part of the future studies objectives. Meanwhile, the proposed method considered the use of single diode model for implementation simplicity. It is also suggested that double diode model can be used for further improvement of the current techniques. However, it should be borne in mind that this may require advanced and complex programming. Thanks. Here are some of the selected references from this study. Now, the modeling algorithm. The algorithm was simultaneously implemented in MATLAB R version R2020A, running on both a MacBook and a Lenovo laptop PC. Thanks for listening. Have any questions, you can ask.
Thank you, dear Mr. Musa Adam, for this nice presentation. Any question for colleague Musa Adam? Chat is empty. Okay, I will ask you one question.
Okay.
Could you please show once again this slide with the conclusions?
With what? With
last one. Before, thank you for your attention. The last one.
The last one, right?
Yeah, the last one. Just one question about this, the second conclusion. You said difference between modeled and actual measurements data. You have used manufacturers' data sheets as measurement data. Have I right or no?
Yes, the manufacturer's data is the actual measurement data.
Yeah. As I saw, you got a very nice agreement between results. Is your program code that you developed in MATLAB available, or just for your purposes?
Sorry? Yeah, it can be available. Yeah, it's available and it can be shared.
Available. Okay.
Yeah.
Thank you. That's all from my side.
Yeah,
Thank you very much, dear
You're welcome.
Mr. Musa Adam. The next presenter is Dan Salisteanu, and he comes from Romania. The paper is three-level inverter, control techniques, design, analysis, and comparisons. Are you here, colleague Salisteanu?
Yes, dear professor, thank you very much.
Welcome, please. Take your time and present your research results.
I hope that my presentation is visible now.
You shared the screen with us.
Thank you. This paper was written by the authors from the University of Craiova and from the Research and Development Department of a company Indaeltra Craiova, with many products in the field of power electronics. The outline of my presentation is as follows. After a short introduction, I will present the inverter control simulation schemes. After that, a short discussion about the control laws design and tuning. in order to assess the performance, the quality evolution of the inverter system, I will present some criteria. And the main part of the paper is related to the simulation results and comparisons. In this work, we address design of control techniques for inverters. The multi-level power converters are, as you know, main elements of high voltage electric drive and power supply systems. In order to obtain an accurate control system, it is very important in the first stage to use simulation and specific computer-aided design tools. So in this work, a detailed software model of a 3-level inverter is designed and then used in order to test some control techniques. These control techniques are integrated in the form of PID controllers, and we used some tuning methods in order to obtain the optimal parameters in 2 specific simulation cases: a multi-level inverter with a linear load and respectively with an asynchronous motor load. And as you will see, we have analysis and some comparisons of the quality criteria. Regarding the inverter control simulation schemes, it is very important to have such inverters because they are requested by the market for several industrial applications. And in this context, we have a collaboration, our university, with this company Inda Eltra Craiova, and we intend to design a prototype of this 3-level inverter. We designed software model with some main parts, such as a 3-level power inverter in neutral point clamped topology, the load, which is a linear load and asynchronous motor, the pulse width modulation command block, and the control loop. In the case of linear load, the controlled variable is the output voltage. And for the load with the induction motor, we have as control variable the motor speed. Of course, according to the strategy of a constant ratio between voltage and frequency. And in this figure, you can see the software model developed in MATLAB Simulink. And the main blocks are the pulse width modulation command block, the power 3-level inverter, the load. Here the load is the asynchronous motor, but in the second simulation case, we will use a 3-phase RL load. And in the lower part of this diagram, we have the implementation of a classical PID controller with a lot of blocks, with saturation and so on. And of course, we have here a lot of measuring block, output voltages, some step sources and scopes for the main variables. In figure 2, you can observe 2 important diagrams. The diagram of the pulse width modulation command block and the 3-level neutral point clamped power inverter. These 2 blocks are linked via the command signals for 12 IGBTs in the inverter legs. And it is important to see that the fundamental harmonic of the inverter output voltage in time domain is obtained as in figure 3 by using a numerical low-pass filter. In this simulation model, we build a software model with a lot of improvements. For example, we use the real switches with proper snubber elements. We use the continuous time domain integration with the variable step. We use saturation blocks for the PID controller. In section 3 of this presentation, I will present you some issues about the PID controllers. These, of course, these proportional integral derivative control laws are well known. And here in the equation 1, 2, 3, 4, and 5, you have the main relations concerning the transfer function of these PID controllers with some main parameters of design, such as proportional gain, integral gain, derivative gain, and of course some time constants such as reset time and derivative time. These controllers are very good, but in order to implement these PID controllers in practice, we need the values of the parameters. And we can use, for example, some tuning methods when we know the model of the process, such as Opelt, Kopelovich, Pesant, and so on. But of great importance for inverter control are the heuristic methods, because we don't have a full mathematical model of the inverter. So we can use some tuning methods which can be applied without the knowledge of the plant model. And in our work, we used three tuning methods: Nichols, Ziegler-Nichols, and Hokushin method. For example, in table 1, you have the value of the control parameters for Nichols method. And in the paper, you can see also the other two methods. In section 4, we discuss about the quality criteria and performances for control system, because it's very important not only to close the loop, but also to assess the performances of our control systems. And usually you can use two types of criteria: global quality criteria. These are integral or summation criteria given by the general relation 6. And usually they are expressed in these forms of integral errors. In equation 7 to 10, you have all the 4 integral errors used in our study. Of course, from the engineering point of view, many times it's easier to calculate, to compute the local quality criteria, such as position gain coefficient, the position state error, and of course, other local quality criteria. In figure 4, you have the classical form of a closed loop system with the transfer function of the controller, the transfer function of the plant, which is not known. And of course, here we have a transfer function with respect to the disturbance. Other criteria used in our study are the overshoot, rise time, and the settling time. And these criteria are defined in figure 5. The main results of our paper are represented here in simulation results and comparisons. To control the multi-level inverter, we used in simulation several schemes with P, PI, and PID controllers and different practical tuning methods. And we have 2 simulation cases. We try to assess the control performance for the multi-level inverter with RL load. And here the control goal is to regulate the effective voltage at the inverter output. And the second case is to evaluate the control performance for the inverter with motor load. And in this particular case, the control goal is to regulate the angular speed. In the first case, we provided the voltage feedback loop with a PID controller, and we try to simulate a target with an intermediate circuit voltage of 300 volts. And in this slide, you can see in figure 6 some simulation results. In the left panel, we have the results obtained with the P controller with the Nichols tuning method. And in the right panel, you have the results for the output and the set point, of course, when we used a PI controller with Nichols tuning method. You can see that in the first case, we have a not zero, not null steady state error. And in the second case, when you use the PI controller, we can obtain an almost null steady state error. Of course, the overshoot is bigger in this particular case. In figure 7, we have another set of simulations. In the left, the PI control law with Ziegler-Nichols tuning method, and in the right panel, the PI controller with the Hokushin tuning method. Of course, we have here some slight oscillation, but we cannot assess the quality of the control only by viewing this kind of evolution. So in table 2 and table 3, we computed all these local and global criteria. Steady state error, overshoot, rise time, and in the second case, the integral errors. From the analysis of these criteria, it can be concluded that the Nichols tuned PI controller enables the best accuracy performance. And the Ziegler-Nichols PI controller achieves the accuracy performance under the condition of a lower overshoot. But the advantages of integral criteria is that they can capture the behavior of the error through the entire evolution range. And in this case, the PI regulator with Nichols tuning is the best choice. The second case is dedicated to the performance analysis when we use an inverter with motor load. And here the rotational speed feedback loop is provided only with a PI controller because we observed that the derivative component leads to some oscillatory behavior of the output. And in figure 8, you can see the evolution of the output versus step set point in the case of P controller with Nichols tuning. And in figure 9, you can see the evolution of the output versus reference when we use PI controller with Ziegler-Nichols and with the Hokushin method respectively. Of course, these are a realistic evolution of the output because we introduced in the simulation model a lot of realistic elements. From the criteria analysis point of view, in table 4 and 5, you have all the local and global criteria. And the conclusion in this case is that we have a surprisingly good behavior of the P controller with tuning by Nichols method. But from the point of view of global criteria, we obtained the best results with the PI controller with the modified Hokushin tuning method. All these analysis and simulation are just the first stage of the development of the prototype in our project. And here in figure 10, you can see the experimental setup, which is almost ready at the Indial Track company. And now we are in the stage of testing and validation these simulation models on a real environment. And finally, the conclusions. The controllers with better control results are the PI type in both simulation case, and the derivative control components do not give adequate results. For the first case, when we have linear load, we obtain the best results with PI controller with Nichols method, and in the case of motor load with the PI control low tuned via the modified Hokushin method. These obtained results are realistic because we have nonlinearities, saturations, which are present in the closed loop system. And of course, if it is necessary to obtain superior performance for this closed loop control system, it is necessary to design more advanced and nonlinear control laws. Further research will target the experimental test with the functional 3-level inverter, which will be characterized by some innovative features. Thank you very much for your attention.
Thank you, dear colleague Salesteanu. Do you have, dear colleagues, any question for Professor Salesteanu? Chat is empty. And we have just time for one more presentation. I have no time to ask, but very interesting. Thank you. Very, very interesting was your presentation, dear Professor. Next presenter.
Thank you very much.
I will introduce. You're welcome. I will introduce next presenter. Next presenter comes from Slovakia. and he is Richard Zelnik. He will present the following paper: Snubber design for flyback converter. Are you here, dear colleague Zelnik?
Yes, do you hear me?
Yeah, of course.
Thank you.
You're welcome.
Now I share my screen.
Yeah, we're waiting with that.
See you my screen?
Yeah, you shared it with us. Please take your time and present your research results.
So, good afternoon, everybody. My name is Richard Zelnik, and I am PhD student at University in Žilina in Slovakia. And at the beginning, I would quickly, So at the beginning, I would quickly go through the points of the presentation that are, and I will present to you the article Snubber design for flyback converter. The outline of presentation is short: introduction and application, simulation, practical design, and conclusion. So at first, I say something about the application. The power supply was used in the application for the control system of three-phase inverter system, which provide the power to its control and auxiliary circuits. It has a wide input power supply up to 700 volts. Its task was to power the sensitive electronics, and therefore it was necessary to ensure its proper functionality, which includes the design of protection circuits. And I would say all PWM converters have non-ideal parasitics that lead the ringing waveforms that must be properly suppressed. Without this, semiconductors can be prone to failure and noise levels will be higher than necessary. In this article, we will talk about the practical design techniques for the most commonly used snubber and clamp circuits for the flyback converter. So the article focuses on the practical and efficient design of snubbers and flyback converter topologies. In the first step, we simulated the power part of the converter simulation program in LT-SPICE. The simulation program supports the real models of diodes, transistors, and their parasitic properties. The simulation demonstrates only the effect of leakage inductance on the overvoltage of the primary switching elements, in our case, the MOSFET.
I'm sorry, may I ask you to switch on the camera?
Sorry?
May I ask you to switch on camera?
Okay.
Okay, thank you.
On the left, you can see the effect of leakage inductance on the voltage profile on MOSFET and without the use of snubbers. On the right side, you can see the waveform with the protection circuits used, which will significantly affect the oscillation and overvoltage peaks on the switching elements. Practical design. First of all, it's necessary to analyze the courses of switching element, which consists of three basic voltages. The upper corner shows the right corner shows the real waveform without the use of snubbers and clamping circuits. And below this figure is the composition of the waveform, which consists of VDL, it's DC link voltage, VRO is reflected voltage, and VOS is overshoot voltage caused by leakage inductance. In the first case, it is necessary to design an RC snubber which ensures the reduction of oscillation arising the transistor caused by leakage inductance and parasitic capacitance. Requirements of design: the RC snubber are simple. Choose a resistor to properly dump the ring and select a capacitor and make sure the dissipation of the network is not excessive. For low frequency application can be used decimal boxes, and values are determined empirically, but at higher frequencies a more analytical approach is needed. As you can see, when calculating the RC snubber, we need to know the frequency of oscillation as shown in the figure on the right, and the leakage inductance of the transformer. Here it is possible to find out in two ways. The first of them is to measure the leakage inductance with an LCR meter by connecting the LCR meter to primary winding of the transformer and shorting all other windings. This we get the measured value of leakage inductance. Subsequently, we use simply formulas to calculate the values of the elements snubber. But if it's not possible to use an LCR meter, we can use a more analytical way to determine the leakage inductance of the transformer. We are primarily interested in the parasitic elements in the circuit, where LLK is total leakage inductance, comprised of PCB trace inductance, Davis-Pekich inductance. Let me see. CLK parasitic capacitance is mainly due to output capacitance of MOSFET. Before we can design the snubber, we must first determine CLK and LLK, as you can see in equation. We could attempt to measure CLK and LK directly, but a more elegant method can be used. For this LC circuit, we know that, as you can see in first equation, where if ring 0 is the frequency of oscillation without a snubber in place. If we edit an extra additional capacitor across transistor, the initial oscillation frequency from F ring 0 to F ring 1, where F ring 0 is less than F ring 1, and resonant frequency will change. So if we measure F ring 0, then add the NO, the additional capacitor, and measure F ring 1, we can determine CLK and LLK. So following this calculation, we determine snubber resistor, where we can determine the degree of damping of oscillation using the zeta parameter. We calculate the snubber capacitor value as in the previous case. Here I would mention that the measured leakage inductance using the LCR meter was 8.3 microhenry, and the calculated course was 7.8 microhenry. So both of methods are suitable for use. There can see a comparison of waveforms before and after using the RC snubber, where we record a significant reduction in oscillation and also a reduction in overvoltage. The same procedure can be used for the design of the snubber for secondary diodes. Now, primary design primary LCD clamp circuit. In figure, you can see the RCD clamping overvoltage circuit, this blue part, which has the task of eliminating the overvoltage peak on the transistor, which is caused by leakage inductance. The RCD clamping circuit works by absorbing a current flowing through the leakage inductance. As soon as the voltage on the transistor drain reaches the voltage at point X, sum of the DC link voltage and the capacitor voltage, the diode starts to conduct the limit, the over voltage. We must consider that the capacitor is large enough so that its voltage does not change significantly during one switching cycle. The results of design RCD complex circuits, the waveform is measured at the input test voltage of 300 volts, and there can be seen the limitation of the over voltage peak, which can be seen on the picture on the right side. In conclusion, the article focuses on the practical design, efficient design of snubbers in flyback converter topologies. It includes a calculation, simulation, and practical verification to consider two tested methods for detection leakage inductance, and it was a confirmed calculation by measurements on a physical model of the flyback converter. Thank you for your attention.
Thank you very much for your very interesting presentation, dear Mr. Zelnik. Any question for Mr. Zelnik from others? Chat is empty again. One question from my side. Could you please show once again, I think, 5th or 6th slide? There you compared this snubber and without snubber. The first one. Yeah, this. Without snubber and this snubber. For instance, you showed the waves with and without snubber. For example, these two figures are so different. Did you say some words about application of this in practice?
Sorry?
About your findings. This solution with the snubber, there we can find it in practice. In which devices?
In which devices? So in a flyback converter, for example.
Is it possible to buy, for example, converter with this snubber? All converters available on the market are without it.
Sorry,
is this originally your finding or is known before?
This is sorry. Is known before, but it's from more articles. When I designed flyback converter, I won't know how to design a snubber, so I find how it say.
For example, this is very useful. Results show that if you decrease level of waveforms on this one, this is very useful, and I believe that manufacturers, if have this, will improve their devices, converters significantly. Okay, that's all.
Thank you.
Any question more for Mr. Zelnik? No questions. I would like now to conclude this session and to say thanks to everybody. You presented very nice papers today, and I believe that our work today was interesting for all listeners. Thank you very much for attendance, and now I'm officially closing the session of Power Electronics. Goodbye.
Thank you, Dardan.
You're welcome, dear Darius.
Bye.
Sorry for interruption of my connection. In Serbia, we have always some problems. or with electricity supply or with internet suppliers. Yeah. Who will? Okay, bye. Have a nice day.
You too. Bye.